It can go, sir. It can go, sir. No, go, sir. You can go. You can raise it. We have to move it. Sir, just 2 minutes. Just 2 minutes. Sharat. ಬರ್ಲಿಲ್ವಾ ಸರ್ ಫಿಸಿಕ್ಸ್ ಹೊಸ ಕೊಡ್ತೀನಿ ಲಿಂಕ್ ಸಿಸ್ಟಮ್ ಮಾರ್ಕ್ ಇದೆಯಲ್ಲ ಅಷ್ಟೇ ಮಾರ್ಕ್ ಬಿಟ್ರು ಅಲ್ಸಂಗಿಲ್ಲ Sasha?
ಸರ್ ಅದು ಲೈವ್ ಬರಲಿ ಆಮೇಲೆ ಮಾತಾಡ್ತೀವಿ ಆಯ್ತಾ
Hello students, we discuss question number 3 in paper 1. First you read the question. A solid cylinder of radius r rolls without slipping with a center of mass speed v0 to gr by 3 on a horizontal surface with a vertical edge as shown in figure. Here g is acceleration due to gravity at the moment when the cylinder loses contact with the surface of the rotation around the corner. The speed of center of mass is. Now I explain the solution. Just see. It is a surface and this cylinder is rolling with velocity v0, suppose like this one. At the end, when it reaches at this point, its center is here. Like this. But here surface end, so it starts toppling about this. When it starts toppling about this, then suppose at this moment it loses the contact and its center is, suppose this one, initial center is here. Suppose this angle is theta and at this point velocity is v0 and at this point velocity is v. Till this instant rolling continue and we apply law of conservation of energy. So loss in potential energy mgr 1 minus cos theta is equal to kinetic energy of cylinder is half mv naught square plus half I omega square. So half mr square, omega is v square by r square, that is equal to 3 by 4 mv square. Here we know. So we write here 3 by 4 mv square minus v naught square. Right? This loss in potential energy is equal to gaining kinetic energy. At this point, contact break. So n becomes 0. Here mg. This angle is theta. So this angle is theta. Mg cos theta. At this instant, provides centripetal force because up to this instant, center of mass moving on a circle. Mg cos theta is equal to mv square by r. And after solving these two equations, you got cos theta is 5 by 7 and v is equal to root 5 by 7 gr. So it is the answer.
Recorded and uploaded. Start, sir.
Yeah.
Questions, please. Questions, please. Okay, so JEE Advanced 2026, paper 1, question number 8, physics. The question says, the electric field associated with an electromagnetic wave traveling in vacuum is given by E naught sine 3y plus 4z plus omega t I cap. So they have given electric field as E naught sine. So
You want
questions, please. Only questions, please. Nothing else.
options? Okay.
Zoom in, full screen.
Yes.
Sine 3y plus 4z plus omega t I cap, where omega is the angular frequency. All quantities are in SI units. The correct statements about the wave is or are. So they have given the speed of light in vacuum as 3 into 10 power 8 meter per second. So option A, the wave is traveling in minus 1 by 5, 3j cap plus 4k cap direction. Now, how do we judge the direction in which the wave is traveling? We can compare this with standard equation. I could say, standard equation for electric field could be treated as E naught sine, in 3D space, it could be omega t minus k vector dot r vector times n cap. N cap is the direction of electric field fluctuation, whereas r vector is the position vector of point at which the electric field is calculated, or that light is traveling through that point position coordinates. K vector is the wave vector for that wave. Now, for this problem, electric field is fluctuating in I cap direction, x direction. So, electric field fluctuates in a direction perpendicular to wave velocity, and k vector will be in the direction of wave velocity. So, we could write k vector dot r cap as k vector dot r vector as k vector could be understood. Well, k vector could in general be kx I cap plus ky j cap plus kz k cap. But as we know, n cap, the electric field fluctuates in x direction, that was I cap. So velocity of wave will be perpendicular to x. So x component of velocity of wave will be 0. So for wave vector also, x component will be 0. So this quantity will be 0. K vector could then be understood as ky j cap plus kz k cap for this problem, as electric field direction is given. And then r vector for any point through which that light wave is passing can be given as x I cap plus y j cap plus z k cap, assuming the coordinates of the point are x comma y comma z. So what would be k vector dot r vector? We could write k vector dot r vector as, so x into 0, then there will be y ky plus z kz, that is k vector dot r vector, and comparing it with the original equation given, we can understand. So this given in the question 3y plus 4z is minus of k vector dot r vector. So that's minus of 3y plus 4z. Now comparing both these equations, we could say ky equals 3 and kz equals 4. We get y coordinate, z coordinate, ky and kz. So the wave is traveling in that direction. So in this case, we get 3y plus 4z as minus k vector dot r vector. So option A, the wave is traveling in minus 1 by 5, 3j cap plus 4k cap direction. Now we get y coordinate and y component and z component of k vector as 3 and 4. So 3i cap plus 3j cap plus 4k cap is fine. But as these coordinates are positive, the wave should be traveling in negative directions of that, right? So in this case, we get ky equals minus 3, kz equals minus 4. There was a minus sign in between. So option A, when we want to find the direction in which the wave is traveling, so k vector's direction alone, k vector for this problem appears to be minus 3i cap, minus 3j cap, minus 4 k cap. If we want direction alone, so we have to get unit vector in that direction, divide by its magnitude. Option A appears to be correct. So magnitude of k vector is 5. Option A is correct. Then option B, the magnitude of the wave vector is 0.5. Magnitude of wave vector is in front of us, 3j cap, minus 3j cap, minus 4k cap. So the magnitude is 5. If k vector's magnitude is 5, magnitude of wave vector can't be 0.5. Option B is wrong. It should have been 5. B is not correct. Then option C, the value of omega. How do we get omega? We know for any wave, we get v, speed of the wave, equals omega divided by k. So omega can be calculated as v times k. If you just want magnitudes and all, so speed of light in vacuum 3 into 10 power 8 multiplied by k. K value is given as in magnitudes, we just got it as 5. So we get 15 into 10 power 8. That is basically 1.5 into 10 power 9. So 1.5 into 10 power 9 radian per second. So that will be option C is also correct. The magnetic field associated with this wave is given by. Now, what things do we know about magnetic field? Its magnitude and direction. First of all, magnitude of magnetic field could be given something like this. Speed of light will be magnitude of electric field amplitude divided by magnetic field amplitude. So we get B naught equals E naught divided by C. That part is understandable. Then the phase of magnetic field fluctuation will be same as the phase of electric field fluctuation. So that 3y plus 4z plus omega t part is common as that of electric field. That part is also fine. Now the only thing we have to change is direction for magnetic field. Well, magnetic field's direction we can get it as E naught cap cross B naught cap should be the direction of k cap. So right hand thumb rule for directions of electric field, magnetic field and the wave propagation relations. So we get E naught cap cross B naught cap equals k cap. And if we check with this equation, E naught cap is E naught cap. So direction of E naught vector is along I cap. Then B naught cap we can just write some bx I cap plus b by j cap plus bz k cap, and we can compare that with k cap's direction. Direction of wave propagation. Wave propagation is direction of k vector. So that's minus 3 j cap minus 4 k cap divided by 5. Well, we can solve all that, but do we really need to? If we check the last part of the direction, it should have been a unit vector, that 4j cap minus 3k cap. So even if the direction cosines may appear to be in relation, in proportion, but still it's not a unit vector. 4j cap minus 3k cap is not a unit vector. So overall that affects the magnitude of magnetic field. So it won't be correct, right? Even if that was correct, the denominator should have been 5. Well, if we want to check, we could also go in details. So I could write cross product first, I cap, j cap, k cap, E naught cap. E naught electric field is only along x-axis. So electric field is only along x-axis. We could write E naught, then j cap 0, y component 0, z component 0 for electric field vector, right? So along axis, amplitude is E naught. Well, we want to get unit vector only in that direction, right? We'll treat it as 1. And then B naught cap, magnetic field. We don't know the direction, but we know for sure it has to be perpendicular to electric field and it has to be perpendicular to k vector as well. But for now, I'll write bx, by, and bz, and such that we know this has to be in the direction of k cap. So direction of k cap is minus 3 j cap minus 4 k cap divided by 5. This will be k cap. So we have to evaluate this, and we understand root of bx squared plus by squared plus bz squared should be equal to 1. Besides, if electric field is only along x-axis, there cannot be magnetic field along x-axis. Both the fields should be perpendicular to each other. So bx will anyways be equal to 0. Well, I'll substitute 0 here itself. So we can write this will be I cap into 0 minus 0 nothing minus j cap into bz minus 0. So minus bz j cap and then plus k cap into by minus 0. So plus by k cap. That should be minus 3 j cap minus 4 k cap divided by 5. Besides, root of bz square plus by square, will be equal to 1. So we can tally both the sides. Turns out bz will be 3 by 5 and by will be minus 4 by 5. So that doesn't appear to be matching with the option. First of all, that 5 is also missing in the solution. So we would get bz as 3 by 5 for j cap. We are getting 3 by 5. Okay, so let us see again. Bz is 3 by 5. We're getting it right. J cap bz 0. So that's fine. Minus bz into j cap and k cap into by. So we are getting by as minus 4 by 5. E naught cap cross b naught cap is k cap. So bz by. So this doesn't appear to be matching with option D. So the answer here will be A is correct, C is correct, B and D will be wrong.
So
Which? Oh, yes, sir. This is camera.
the solution. Okay. So let's have a look at the solution of the 10th one. This is
You can read one question.
read from the question.
It will be visible.
Okay.
Okay, you just read on the you want the question paper?
Yeah, is there
No, no, no. The question is there, no?
the question is not there. I can read from the phone.
Oh.
That's not right. You just read the question, then you just.
Okay. Just
Yes.
okay. So let's have a look at the 10th question. This is based on a cascading Carnot engine. This was asked previously in JEE Mains as well. It says, shown in the figure are 5 Carnot engines with efficiency eta, same number of cycles per unit time, operating between 6 heat reservoirs. The amount of heat, the heat released by the first one is absorbed by the second one, and so on. If the heat absorbed by the first engine is Q naught, and the total amount of work done is W, then the net efficiency of the system. The net efficiency is total work output by heat input is given as 211 by 243. And you have to find what is the efficiency of each Carnot engine. So this is first reservoir, some Q naught amount of heat is absorbed here, and the work output is in W1. Some Q1 amount of heat is rejected here to the second reservoir, and that becomes the input for the next Carnot engine, where the output work is in W2, and some Q2 amount of heat is rejected, and so on all the way up to the last one, where some Q5 amount of heat is rejected. So let's just write down whatever is given. It says for each engine, the efficiency is the same, eta. So that is W1 by one minus Q1 by Q naught, which is also the same as 1 minus Q2 by Q1, which is the output and input for the second one, so on, all the way up to the last one, 1 minus Q5 by Q4. The net efficiency is the net work output by the heat input to this entire system. This will be up to Q5. This adding up the work extracted from each stage. And for the first one, this will be Q naught minus Q1. For the second one, it is Q1 minus Q2, so on, up to the last one, where it is Q4 minus Q5. All the cross terms cancel, and the first and the last term is what you have left. And this is given as 211 by 243. But to get an expression for Q5 by Q naught, just notice that from the first one, you can write Q1 by Q naught is 1 minus eta, and this is also Q2 by Q1, Q3 by Q2, so on up to Q5 by Q4. So if you multiply all these terms, you get Q5 by Q0 is Q5 by Q4 into Q4 by Q3. This is just 1 minus eta power 5. Right? So it's given 211 by 243 is 1 minus eta power 5. That gives you 1 minus eta power 5 as 1 minus 211 by 243. That is 32 by 243. Okay. So we need eta. The fifth root of this is 1 minus eta is 2 by 243. 2 by 3 or eta is 1 by 3. Yeah.
Next question now. Yes, sir. Once again, short sir.
Yeah.
Because his mic, my mic is mute. Sir, short sir.
So question number 11 says there's a insulated container fitted with a thermally conducting immovable partition. So the first one, it's thermally conducting but it's fixed, P1. And the second one is thermally insulated and free to move. The partition P1's conductivity is K, cross-section area is A, and width is X. Both the partitions have 1 mole of monoatomic gas, and P2 is free to move, so it will move such that the pressure, internal pressure is equal to the external pressure, which is the atmospheric pressure. It says the initial difference in temperatures between S1 and S2 is delta T naught. The time it takes for the temperature difference to drop to delta T naught by 2 is given as some Nx R by Ka, and we are supposed to solve for N. So that's the question. This is let's say initially the temperature here was some T1 naught, T2 naught. So let's write that down, initial temperature difference. T1 naught. This is called given as delta T naught. For ease of notation, I just call that theta naught. As heat flows from here, the temperature here decreases, the temperature here increases, and this piston will slowly move outward to keep the pressure constant. So this is an isochoric process, and this is an isobaric process. So each of them contains 1 mole of ideal gas. So later, let's say the temperature here is some T1, the temperature here is some T2. I can write T1 minus T2 is some theta, which is a temperature difference at a later instant. Differentiate throughout with respect to time. You get dt1 by dt minus dt2 by dt equals T theta by dt. Also, I can write dq by dt, the rate at which heat is transferred across this. Fourier's law, heat conduction, you can write this as Ka by x times temperature difference at that instant, that is theta, which is also equal to, as this loses heat, the temperature of the compartment on the left will decrease. So I'll write minus 3 by 2 R d T1, that is NCV dt for the isochoric process, which will also be equal to plus 5 by 2 R d T2, isobaric process for S2. And from here, I can replace dt2 as minus of 3 by 5 times dt1, which will give me an expression for d theta in terms of dt. dt2 is minus 3 by 5 dt1. Substitute that here, 1 plus 3 by 5, 8 by 5. Now I can. So I need to find the temperature difference as a function of time. Right? So I need an expression with d theta by dt and theta. So I'll write Ka x by theta is minus 3 by 2 r. This is called differentiated just like the time. D theta by d1 by dt. And dt1 by dt is 5 by 8 d theta by dt. So rearrange the expression to get dt is minus 15 r x by 16 k a d theta by theta. And once you see this, you must be able to recognize quickly that, so this is initially some theta naught. We want to find out how much time it takes to drop to half the initial value. 0 t is minus 15 by 16 r x by k a. ln, upper limit, lower limit, you get a ln of half, which is minus ln of 2. So this will be 15 by 16 ln 2 times r x by k a. The value of ln2 is given in the problem as 0.7. So if you substitute that, you get this as 0.656 times rx by k a.
Hello students, we will discuss question number 2, paper 1. First we read the question.
consider a circuit consisting of a capacitor of capacitance C and a coil with n turns per unit length, cross section area S and length D, where D square must greater than S. There is another coil of length D by 2, cross section area S by 2, and 2n turns per unit length completely inside the larger coil as shown in figure. The ends of the smaller coil are connected with each other by an insulated conducting wire. The self-inductance of larger coil is L. Neglecting SFX and all the ohmic resistances, the resonant frequency of the circuit is one coil is this one, and other coil inside this. Other coil is inside this, and it is short circuited, and it is capacitor, and this is a source, AC source. First, we see this. Consider it on this part. Suppose two coils like this. Current in this one is I1 and this is I2. If we see about bigger coil, its inductance L1 is mu naught n square area cross section area S into D. It is for bigger coil. For shorter coil, and it is given to L in the question, mu naught 2n square, S is S by 2, D is D by 2, so it is also equal to L. So both coils have self-inductance L, right? Now, second step. In the second case, ABC in the smaller coil, magnetic field due to only bigger coil. So if we find mutual inductance, M is equal to magnetic field due to this is mu naught Ni1. It is magnetic field into its area is S by 2 and number of turns is 2n into D by 2 divided by current I1. And from this we got L by 2. It is second step. Now, third step. A smaller coil is short circuited like this one. So induced EMF, net induced EMF should be 0. So L di2 by dt minus M di1 by dt is equal to 0. Is equal to 0. Here M is L by 2. So you write di2 by dt is equal to L by 2 di1 by dt. So I2 is equal to I1 by 2. Now we find in the next step equivalent inductance for first coil like this one. L equivalent di by dt is equal to L di1 by dt minus M di2 by dt. This is equal to L di1 by dt minus L by 4 di1 by dt. So here we got L equivalent is 3L by 4. So omega is 1 upon root LC, L equivalent into C, that is L equivalent 3L by 4, 3LC, and this one. In this step, second coil is not connected to first coil. When for equivalent we consider only L di1 by dt minus M di2 by dt. It is the answer.
Camera. Oh. Okay, so let's do the ninth question, paper 1, question number 9. So here what we have a pole or a rod inside a liquid. There are two liquids. So just like this, in between there are liquid 1. Let's say this is having a density of 6 rho and this is having a density of 2 rho and the rod is having a density of rho. So we have something like this. What we are going to do is we are going to tilt it a little, something like this. We will be tilting it at an angle theta. So what happened means here there will be a buoyant force, right? There will be a buoyant force as well as mg is also acting downward. So what I am going to do is I am only considering this portion. I am only considering this portion from here to here. So at this point, at the midpoint, mg will be acting in downward direction. In this direction you will be getting mg. So instead of mg, what I can write is mg, instead of mg I can write mg will be equals the weight of the rod from where to where, from here to here. That will be rho into, that is the density of the rod, and half of the volume of the rod into g. Like this I can write. So here I will get mg now downward direction, or m, instead of this mg what I can write? I can write rho into v by 2 into g in downward direction. In upward direction what will be the force? The force will be, in upward direction, the force will be, what about the buoyant force, right? Buoyant force will be, I can write buoyant force will be rho into 6 times rho into half of the volume, this is the volume displaced, and g, this will be the buoyant force. So I will call this point A, and at the center of this portion is B. So net force, this is buoyant force, net force at A will be equal to what? 6 rho v by 2 into g minus rho v by 2 into g. That will be 5 times rho v by 2 g. Similarly, you will get another, similarly the same method you will be getting, and net force at B, something like rho into v into g by 2. Why this? Because here we have rho v, rho 2 times rho is the density, right? So that will be the net force here. So but this force will be exactly upward direction. What we are going to do is we will be resolving the force perpendicular and along the direction of the rod. So there will be a theta, and the component of the force, perpendicular component will be, the perpendicular component will be 5 rho v into g by 2 sin theta. And this is the perpendicular component at A, and the perpendicular component at B will be what? Saying rho vg by 2 into sin theta. So now we are going to discuss about the restoring torque. Restoring torque. Torque will be equal to what? Force into displacement, right? So up to the point here, the displacement will be L by 4. So you will be getting 5 rho vg by 2 sin theta into L by 2. Plus one more torque is there, that will be rho v g by 2 sin theta into, up to this point B, that will be 3L by 4. So if you are observing here it will be not 2, it will be 4. So you will be getting the denominators are 8. So what you can do? You can add it directly. So you will be getting tau will be equals 5 plus 3, that will be 8 rho vg by 8 into sin theta into L. So 8 will cancel, and for the small angle approximation you will be getting what? This angle which we are tilting. This angle is very small, so you will get rho vg L into theta. This will be the restoring torque. Because of the restoring torque there will be a negative sign. So we know that I alpha equals minus rho vg L theta. So take it the other side. So I alpha plus rho Vg L theta. So now this is the type of standard equation. This is the standard equation, right? So I need to divide it with I in order to get the omega. The standard equation is something like this: omega square theta equal to 0. So we are comparing it with this equation. So I value will be what? I value. I will be ml square by 3. M is nothing but rho v L square by 3. So we'll get omega square will be something rho v g L divided by rho v L square by 3. So omega square will be what? Rho will cancel, Vb, and G will be there. There will be this one will also cancel. You will be getting 3 times G by L. This will be the omega square. So we got the omega square. Then what we can do right now? We got that value. So we got omega. Then omega will be root over 3g by L. So time period we can get 2 pi root over L by 3g. So n will be what? Root 3. So we can say d is equal to 1.73. So the answer is 1.73. That's it. Thank you.
Sure, sir.
So we are discussing question number 15 now. So in question number 15, you can see in left hand side column, it contains 4 conducting loops, all right, and the magnetic field is in positive z direction. Okay, so suppose if I draw a diagram, something like this. And magnetic field is outwards. Now, think it like this. So this is the current positioning of loop. So from here till the loop attains this position, like it is rotating, right? So till it rotates from here till here, the magnetic flux through this loop will be 0. Magnetic flux will only appear when this loop is not totally, like it just leans from vertical into rightward direction, and it is totally horizontal like this. Okay, so for this part, understood. So we can see that the current will be there for half the time. Option number 3, can we show option number 3? Yes. So current will be produced for half the value of positioning of the loop, for half the positioning. For the other half, again magnetic field the current becomes 0. So only one option is justified here. And yeah, there is a word used here, induced current, so you may think that Lenz's law will be applied over here, but they have not mentioned about whether to take the direction of anti-clockwise current as positive or the clockwise current as positive. So taking all the conclusion, option 3 is the best option. So for P, it becomes option number 3. Okay, we'll go up now. Yes, now you can see the diagram number Q. So similarly, for diagram number Q, the loop looks like this. This angle is 60 degree and this angle is 60 degree. Okay. So now for 360 degree, there is a complete T. So for 60 degree, this becomes T by 6. So the current will be there for T by 6 when, again, you can imagine this part of loop comes inside and there is nothing here. So current will be always 0 here. Okay. So going by this logic, you can see option number 1. Option number 1. Go up. Option number 1. Okay. So for Q, it becomes option number 1. Now the third diagram is yes. So third diagram. This is 60 degree. Now here the current will be only for, again you can say T by 6. So for T by 6 there will be current, and for the remaining there will be no current. Can you show option number 1 and 2 once?
1 and 2.
No, for Q answer will be option number 2. Sorry. For Q answer will be option number 2. Because there are 2 loops like this, no? So current will be initially non-zero, then current becomes 0 here, and then current becomes non-zero. Okay, so this is the diagram for 2. So for the previous one, this one. It is also 60. So current will be there for this much part, there is no current for this much part, and again there is a current for this much part. So there is a current for the first T by 6 part, then current for the last T by 6 part, and there is no current for this part, you know. So here, and this is your current over I. So this becomes 2, and for R, the diagram is like this. So for R, it becomes option number 1, right? Because option number 1 will there will be current only for T by 6 part and no current for the remaining part, right? So it will be like this. And when the loop goes downward, exact same current will be negative, okay? Which is there in all the options 3, 2, and 1. And in option number R, I mean option number S. Option number S. Can you show me the S diagram? Yes. The diagram looks like this. The diagram looks like this. So this is 60 degrees. So you know whatever current will get for this, exactly opposite current will get for this. So the net current will be 0 here, and we'll get option number 4. So S becomes option number 4, and the diagram would look like this. Okay. So which option is there? P3, Q2, R1, S4. Option C is correct. Thank you.
Hello dear students. Yeah. Question number 12. Question number 12, paper 1, JEE Advanced 2026. Alright. JEE Advanced 2026, paper 1, question number 12, physics. Paper 1, physics. Okay. So this is the given data for us. Right. Right circular cone, they have given height of the cone, right? Nothing but h, okay? Right. A charge is distributed, yeah, something like this. If this is the cone, right? This is the cone, charge is distributed here. Yeah, this is circle actually, right? So, charge is distributed. So, surface charge density sigma is nothing but q by a, that is q divided by, yeah, only this surface area, right? So, it has to be pi r h. H is the height given, r is the radius, okay? Surface charge density. Now, it is being rotated. Yeah, this is your point, that is origin. This is nothing but z axis, right? Somewhere here there is a point, right? Let us say that is point P. From here it is at a distance of z, that's what they said, okay? For this what we do is, yeah, can I have a color chalk? For this let us consider some element, the charge element. Yeah, it can be in the shape of a element. Yes, this cone is assumed to be a combination of several elementary rings, right? That's what I am taking here. This is my elementary ring. Yes, this is. Radius of this is small r. Assume it is having a thickness, right, dy, and it is at a height y. Let me use this here, space here. This is at height y from the point O. I will consider this as angle alpha. Observe this one. Tan alpha r by h is equal to small r by y. Capital R by h is equal to small r by y. Okay, so that means y is equal to, you can say, or else you can do one thing. Y is equal to rho. Or else let us directly replace this. Small r is equal to capital R into y by h. Okay, right? Now, due to rotation, yeah, on this elementary ring, yeah, I am putting the shaded portion. Charge, can I take it as dq? dq is equal to sigma, right, multiplied by dA, right? dA is nothing but, yes, this only, area of this strip, okay? Yeah, this is 2 pi r into dy. So, this is sigma into 2 pi r into dy. In place of r, I think I can substitute that here. So, if you do that, yeah, I think we can use the space here. dq can be expressed as sigma into 2 pi into capital R into y by h whole multiplied by dy. Yes, I think up to it's clear. Now this is under rotation. Charge ring under rotation produces magnetic field here. That field I will consider this as, right, dq is equal, yeah, first current di due to rotation of this fellow, it is nothing but dq into omega by 2 pi. Basic formula. Current is produced due to circular motion of charge also, translatory motion as well as circular motion. Circular motion, this is the formula. In place of q, on the ring, distributed charge is not q, it is dq. Q is the distributed charge on the whole surface. On the whole surface, I am considering small elementary ring here. Got it clear? Yes, dq you have to substitute here. Now due to this di, yeah, as if this is current carrying circular coil, this elementary ring producing magnetic field here. So this is Z. So here guys, magnetic field dB, okay, is nothing but mu naught, yes, into ni r square, right, into 2 by r square plus x square whole power 3 by 2, general formula. In place of n number of turns, this is not a circular coil, so n it has to be 1. Mu naught into di into r square, that is r square here, divided by 2 into, yes, maybe if you can take this as small x, 2 into r square plus x square whole power 3 by 2, that's what we consider actually. But this x is equal to, you can put right here only, z minus h. Okay, so if you put x is equal to z minus h, he clearly says that z is far greater than h. So overall what happens is total, yeah, magnetic field dB, approximately you can mention this as mu naught into di whole multiplied by r square divided by 2 into, you can express this as z cube based on the given assumption. Now total magnetic field at P, there are so many elementary rings, right? There are so many. Total magnetic field at P due to all the elements, you have to integrate it. Magnetic field at P, yes, implies magnetic field at P integral dB that goes from 0 to capital R. Okay, so if you want, you can also make use of this expression, right? dr is equal to capital R into dy by h. You can substitute here. Yes, observe this carefully. Yes, here only di is nothing but this one. In place of dy, right, in place of dy, you can substitute dr into h by capital R. In place of y, yes, you can replace this small r into h by capital R. Substitute in, yeah, here itself I will write y is equal to small r into h by capital R. In place of y, substitute here this one, boys. Okay, in place of dy, yes, yeah, you can substitute this dy is equal to dr into h by capital R. If you do the integration, yes, then the result is this. Yeah, I have that with me. Yes, yeah, this will be mu naught q r square omega whole divided by 8 pi z cube. But the given solution for you in the given option, right, yeah, I think I can rub off this part. In the given option, what they have said is, this is n mu naught q r square omega by 4 pi multiplied by z cube. So obviously compare this, n will be equal to 1 by 2. Yes, that is your answer. Okay.
Yes. So JEE Advanced paper 1. Question number 4. A double convex lens made up of glass of refractive index 1.5, lens refractive index 1.5, and radius of curvature 20 centimeter each. So it's a double convex lens immersed in liquid of refractive index NL. Correct plot showing the variation of power in the units of diopter. How to find power in diopter as a function of NL. So to finally get a graph of power versus NL. So here we can just use lens maker's formula 1 by F equals mu of lens by surroundings minus 1 into 1 by R1 minus 1 by R2. This is the formula, lens maker's formula, and 1 by F is power. So I'll just substitute the given values in the equation and we'll get the equation for power. So power is refractive index of lens is given as 1.5 by surrounding is NL minus 1 into 1 by R1. For double convex lens, R1 will be positive, that is given as 20, 1 by 20. I'll convert that to meters so that I'll get the power in diopters, SI unit. So I have to substitute radius in the meters. 1 by 0.2 minus of minus 1 by 0.2. Here for R1, right side positive, R2 will be negative. So here minus will come. You just simplify this, 1.5 by NL minus 1, 2 by 0.2, that is 1.5 by NL minus 1 into 10. Now I'll just substitute. If you see the graphs, NL value starts with 1. Right here. Yes. NL value if I take as 1, then power I am getting from this equation. NL value if it is 1, 1.5 by 1, that is 0.5, sorry 1.5 minus 1 will be 0.5 into 10, 5 will come. For if NL equals 1, power you are getting 5. Then if we substitute NL as 1.5 by 1.5, that is 1, 1 minus 1, 0, power will get 0. And we substitute NL as 2, 1.5 by 2 minus 1 into 10, that is 0.75 minus 1 into 10, that is minus 2.5 will come. So if you look at the graph now, it should start with 5, then 0, then minus 2.5. So when you look at the graph options, A option is matching. Okay, B also is similar, but what is the difference? In B they are given a straight line. And we know from this equation, P is not directly proportional to NL. NL is in the denominator, therefore you will not get a straight line. So only possibility is A curved graph like this with starting value 5, when NL is 0, 5, when NL is 1.5, power is 0, and when NL is 2, power is negative. So option A is only matching. Yes.
Then start, sir. Okay, everybody, see, we have another question, which is question number 5. It is based on Bohr's atom model as well as a little bit of mathematical manipulation. And we have the ideas of modern physics like de Broglie wavelength. So let's try and solve this problem. So we have the given data like consider a hydrogen atom with Vk, Rk, Kk represents the velocity, orbital radius and kinetic energy of the electron in the kth orbit. Then the electron undergoes a transition from nth orbit emitting radiation corresponding to a Lyman series. Considering h to be the Planck's constant and epsilon naught as permittivity of free space, which are the correct statements. So we need to check each and every option here and we'll go for it. Okay. So as you are all aware of this, suppose if we have some nucleus here, especially it is hydrogen atom. Okay. So an electron will be revolving around at some radius, let's say. So here the given data is our electron is in some kth orbit and it is moving with a velocity Vk and radius will be Rk. That's given. Now as this is moving, it can transition from excited state to ground state. So they are saying if it is undergoing a Lyman transition. So you know that Lyman transition from any given energy level, if the transition happens to n equals 1, then we know that it belongs to Lyman series, correct? Now here we have an electron which is orbiting in nth orbit. Okay, from nth orbit it is just jumping to n equals 1. Now we need to just check out the options and see, like, comment on how things will happen with the kinetic energy and de Broglie wavelength and all. Let's have a look into the question. Yeah, so you can see here in the question we need to comment on magnitude of change in kinetic energy of the electron. For that we need an expression for kinetic energy. So let's see like how to get the kinetic energy expression. So we have kinetic energy of the particle which is in the nth orbit is given by half mass of the electron and velocity in the nth orbit squared, right? This is the basic expression for kinetic energy. Now we also know this, the angular momentum of a given electron in the orbit is given by mvr. So we have vn rn because velocity corresponding to nth orbit, radius corresponding to nth orbit, which is equal to nh by 2 pi. And this we know from what? We know this from Bohr's postulate. We know this idea. So we have these two equations, right? After this, let's do a little bit of manipulation of this and rewrite this one in a different way. So I'll just make some space here. So we have kinetic energy expression and angular momentum in the nth orbit, this expression. Okay. So kinetic energy will take the expression half m vn and we'll be writing another v, right? Velocity in the nth orbit. By using this expression, we'll rewrite it. Okay, so we can write velocity in the nth orbit as nh by 2 pi divided by m times of rn. Okay, so we'll have nh by 2 pi divided by m times of rn. M times of rn. This is what we'll get. This is the expression we have for kinetic energy. Let's simplify this. The kinetic energy we will get in the nth orbit as 1 over 4 or nh by 4 pi. nh by 4 pi times we'll have vn by r. Vn by r. So with this expression, we know that kinetic energy will be same as total energy with a negative sign. We also know this, right? So kinetic energy and total energy will be related like this because we are dealing with central forces and these ideas. We have learned this, right? So this is the expression for kinetic energy, this is the expression for total energy. With this, we will first verify our change in kinetic energy. I'll erase this part. So changes happening to our kinetic energy. So delta K meaning kinetic energy in the first orbit minus kinetic energy in the nth orbit, because it is transiting from nth orbit to first orbit, right? So we have kinetic energy in the first orbit, right? So we'll take this expression, put n equals 1 and v1 r1, right? So h by 4 pi and v1 by r1 minus kinetic energy in the nth orbit, exact same relation, we just substitute here. So nh vn by 4 pi times of rn. Just take the common factors, so h by 4 pi outside, so we'll have v1 by r1 minus nvn by rn. So that's our change in kinetic energy. So let's look at the options. So you'll see that the kinetic energy change in the first option as h by 4 pi nvn by rn minus of v1 by r1. Anyways, they are asking magnitude, right? So minus sign, it doesn't matter. So we can just say that magnitude wise, this option is correct. So we can write this is option A, meaning you can write h by 4 pi magnitude wise, because or else we have to write negative. So nvn by rn minus of v1 by r1. So that's the change in kinetic energy. So option A would be right answer. Okay. Now using this logic, we can think of total energy change. So total energy change, if you observe, don't you think from this expression, the total energy change should be exact same value with a negative sign? So again, we'll go back to our options. You can see that change in total energy, the fourth option, option D, we have h by 4 pi times nvn by n minus of v1 by r. This would be the changes happening to the total energy. So what we did, we took final energy of the first orbit, okay, and final, like initial energy in total energy in the nth orbit, and we took the ratio, difference of it. So this is nothing but final E1 minus of En. This is the final energy and this is the initial energy. We are taking the difference of it, and as we express this one, we will get this. So h by 4 pi nvn by rn, this would be rn, right? nvn by rn minus of v1 by r1. So this is the change in total energy we are having. But in the options, if you see, in the options they are giving h by, in the options if you see, it will be h by 2 pi times v1 by r1 minus of nvn by rn, it seems. Meaning they are expressing in magnitude wise, we can reverse this, that is not a problem. But we wanted 4 pi, but in the option it is saying 2 pi, right? Which is not correct. So option D, right? That would be incorrect. Option D would be incorrect. Option A is correct, option D is incorrect. So we are done with two parts of the question. Now let's go with other ideas also. So let's take up the question again. So you'll see that we need to think about now magnitude of change in de Broglie wavelength as well as frequency of radiation emitted in our given situation, right? So I will erase all these things. And we'll think about now de Broglie wavelength. See, de Broglie wavelength is given as h by momentum in the denominator, but here we have velocity of a particle which is moving in the nth orbit, right? So we have h by mvn. So we have already developed kinetic energy in the nth orbit. Kinetic energy in the nth orbit is given as nh by 4 pi times vn by rn. This is the expression that we have already developed this we had just we did in the last section, right? So this expression we have, and velocity of the nth orbit, right? Let us reorganize this in the other way. So we can just write 4 pi kn Rn divided by nh. We are just reorganizing it. Then I'm sure that we all would have memorized this. The radius of electron when it is in some nth orbit, we have it is epsilon naught n squared h squared pi m ze squared. So here z equals 1, right? So we have the expression for radius of the electron moving in an nth orbit in hydrogen atom given by this epsilon naught n squared h squared by pi m z squared. Let's plug this information here and write the value of Vn. Okay, so as we write this one, we'll get 4 pi kn by nh, right? And Rn is given epsilon naught n squared h squared by pi m e squared. Let's simplify this. Let me do some space here. That's Rn. Now n and h gone, so we'll have the pi value also gone. So we'll have 4 kn epsilon naught nh 4 kn epsilon naught nh by m e squared. That's velocity in the nth orbit. Okay, so velocity in the nth orbit we got. Now let's reorganize this a bit. I'll just transfer this m here. So that's our momentum, right? So momentum is 4 kn epsilon naught nh by e squared. So we'll plug this information here and write lambda equals, I'm just substituting nothing much. So mvn would be 4 kn epsilon naught nh and e squared here. Okay, so we finally got lambda n de Broglie wavelength in the nth orbit. If de Broglie wavelength in nth orbit is this value, right, then we can just get rid of this h dependency, and lambda in first orbit would be e squared by 4 epsilon naught. Let me write this n, it is kn and n. If it is first orbit, it would be e squared by 4 epsilon naught k1, right? So changes in the de Broglie wavelength, lambda 1 minus lambda n. This is a final state, this is the initial state. When you take difference of it, you will have e squared by 4 epsilon naught, right? That's the common thing. And you will have, this is the final one, so it is 1 by k1 minus 1 by nkn. This is what we have. But if you look at the options, they have given the changes happening to the de Broglie wavelength as shown, that e squared by 4 epsilon, that's what we have, and 1 by kn minus of 1 by k1 it seems, right? But they are using magnitude, yeah? So they are using magnitude. You can observe that even if I use magnitude here, even if I use magnitude and revert these two, but still n will be missing, right? Since n is missing, we can surely say that option B, right? That because we are checking de Broglie wavelength, that option B, right? That would be wrong. Option B would be wrong option. Okay. Now going further, we'll have to check option C then. So option C, I'll erase a little bit here and make some space and we'll solve it. So I'll erase this part a bit. We know that it is transferred from higher energy nth state to lower energy 1. So we'll have, that is h nu, and energy in the nth orbit, I think we would have memorized this. Energy in the nth orbit. Energy in the nth orbit would be in general Ze squared by 8 pi epsilon naught r, right? In n, because it's just like what, half of the potential energy. So this we know, and negative because the total energy bound state. So I think you would have memorized this. Then we'll just use the difference of this. So h nu would be, say Z equals 1 here in this case. So we'll have final energy this minus of that, right? So E squared minus 8 pi epsilon naught Rn minus plus E squared by 8 pi epsilon naught R1. That's the change, right? So we'll have nu equals, we'll take all the terms common which are present in both the terms. So E squared by 8 pi epsilon naught 1 by R1 minus 1 by Rn, right? And here we'll have h nu, I'll be transferring that h here. So let's check out the options now. So do we have E squared by 8 pi epsilon naught h into 1 by R1 minus 1 by R1 minus 1 by Rn? Check. In option C, if you observe, we have frequency of radiation emitted can be expressed as E squared by 8 pi epsilon naught h 1 by R1 minus 1 by Rn. So absolutely right. So in this question we got option A and option C are correct. Option B and option D are incorrect. So I hope this problem is pretty simple. It had Bohr's atom model idea, and you should know the basic postulates. That is one more thing. Then you should also know the mathematical manipulation. You have to check out the options and see like what best we can do to express in a given terms. So I hope you are enjoying this, and we'll continue with other problems. Stay tuned.
Yeah. Okay, so started. Paper 1, question number 7, physics. A quasi-static cycle of monoatomic ideal gas contains an isothermal process. So first of all, they're telling us the gas is monoatomic. We know degrees of freedom will be 3. Degrees of freedom will be 3. It's monoatomic. Gas contains an isothermal process AB. They have given the graph. I'll copy the graph at first. So y-axis there is pressure, x-axis there is volume. The process is drawn something like this. So this point they are calling as A, this point as B, this point as C. A to B, B to C, C to A is the process direction. At A they have shown the volume is V1. At B and C together it's a vertical line, so the volume is V2. Y-axis pressure, x-axis volume. A quasi-static cycle of monoatomic ideal gas contains an isothermal process AB. So at AB the temperatures will be constant. Did they give how much temperatures? Okay. Followed by an isochoric process BC and an adiabatic process CA as shown in the figure. The volumes of the gas are V1 and V2 at A and B respectively. If the cycle has heat input Q in and output Q out, then the efficiency of the cycle is defined as eta equals Q in minus Q out. That's basically the net work done in the cyclic process, right? Because delta U will be 0. Q net equals W net. The correct statements is or are given. Ln 2 is 0.7. They have given ln 2 value as well. Okay, so let's check the options. Option A, if V2 by V1 is 8, the heat released in the process BC is smaller than the heat absorbed in the process AB. B says for given value of V2 by V1. So every option they are dealing with V2 by V1. It seems okay. For given value of V2 by V1, eta does not depend on temperature of isothermal process. It has efficiency. Okay. And then option C, then temperature of the gas at A is 4 times the temperature of gas at C. And D, they are comparing pressures. So we have to get pressure comparison, temperature comparison, and we have to get eta value and then compare Q values. Okay. So first of all, let's assume temperature. They didn't give anything. We'll assume temperature at A as T1. Process AB is isothermal. So temperature at B will also be T1. Then B to C is isochoric. They are saying the volume will be constant, but the pressure will be changing. Let me call pressure at A as P1, pressure at B as P2, and pressure at C as P3, right? And then at C, the temperature, well, temperatures could also change because it's isochoric, not isothermal anymore. So this is T2, but T2 to T1, C to A will be an adiabatic process. So first, they have given V2 by V1 is 8. The heat released in the process BC, it's smaller than the heat absorbed in the process AB. How do we compare the heats? Okay, so I could say for this complete cyclic process, delta U will be 0 for cyclic process. You know, starting point, ending point of the process will be same. So delta U will be equal to 0. That means Q minus W will be 0. Means Q for the cycle will be equal to W for the cycle. Q for complete cyclic process will be work done for complete cyclic process as well. Now work done for complete cyclic process, it appears that the cycle is clockwise. So for clockwise cycle, the work done by gas will be positive. That means heat is supplied to the gas effectively. Q cycle will also be positive. Heat is effectively supplied to the gas. Now, in the 3 steps, what is really happening with heat? A to B, isothermal process, but volume is increasing. Delta U is 0, but work is positive. So Q is positive. QAB is greater than 0. We know that. And then QBC, from B to C, isochoric process. Pressures are decreasing. Temperatures will be decreasing. So delta U is negative, work done is 0. Delta U is negative, work done is 0. Q will be negative. So QBC is negative, right? So in AB, heat is supplied to gas, BC heat is taken out, and CA is anyways adiabatic, so nothing. So overall, net heat supplied to the gas is heat supplied in AB minus the heat amount removed in BC. And that's what is supposed to be W cycle, but we know work done for complete cyclic process is positive. So can I say heat supplied will be more than heat removed, only then the net heat will be supplied to the gas? Option A is asking us to compare the heat released in process BC, and they are saying it's less than the heat absorbed in process AB. Makes sense? Heat supplied to the gas is more than the heat removed. So option A is correct. I'll write it here. A is correct. Then for a given value of V2 by V1, eta does not depend on the temperature of isothermal process. We have to get eta expression, and then we have to compare pressures and temperature. I think going with comparison of pressure and temperature could be easy things. First things first, right? Easy things first. Let's go with pressure, temperature, volume comparisons. So let's check pressures. What will be relations? They are asking us to compare the pressures between A and B. The process A to B is isothermal. For isothermal process, we know pressure into volume is constant. So I could say P1 V1 equals P2 V2. P1 V1 equals P2 V2. P1 V1 equals P2 V2. Fine. Isothermal process. So we can compare the pressures easily, right? They are asking pressure at A. So they want us to get relation between P1 by P2, pressure at A by pressure at B. That's what they are asking. It's 4 times. Let's verify. P1 by P2 from here will be V2 divided by V1. And what is the V2 by V1 ratio they have given? For option D, V2 by V1 is 8. V2 by V1 is 8. So this thing is 8. So P1 by P2 will be 8. 8 times. So option D is not correct because it's saying the pressure P1 by P2 is 4 times, but actually we are getting 8 times. So D will not be correct. Then let's check the temperature. Option C, temperature relations between points A and C. How do we compare temperatures between points A and C? So between A and C, the process is adiabatic. So maybe we can write adiabatic process relation. For adiabatic process, PV to the power gamma is constant or TV power gamma minus 1 is constant. They have given volume ratio. So let's use TV power gamma minus 1. TV power gamma minus 1 is constant. This we are talking about process CA, right? So I could say T1 V1 to the power gamma minus 1. Monoatomic gas, gamma is 5 by 3, gamma minus 1 is 2 by 3. 2 by 3 equals T2 V2 to the power 2 by 3. So we get T1 and T2. They are asking us to compare temperature at A by temperature of C. So I'll write temperature at A. T1 by T2 is what they are asking. T1 by T2 is V2 by V1 to the power 2 by 3. They have given V2 by V1 as 8. 8 to the power 2 by 3. 8 square is 64. Cube root is 4. So this is basically 4, right? T1 by T2 is 4. Temperature at A is 4 times the temperature of C. Yes, that's correct. Option C is correct. A is correct. C is correct. D is definitely wrong. The one that we have to yet check is B. For a given value, they are asking now efficiency. Now that's the usually lengthier part because we can find the relations at first and then maybe we can use that for finding efficiency. So efficiency, what is the expression in general? They have given it already. We know it in this. So net work done by the gas in cyclic process, that's Q cycle. So Q in minus Q out. Q in minus Q out divided by Q in. So basically 1 minus heat lost divided by heat gained, right? Heat lost, in which state is the gas losing the heat? BC divided by heat gained by gas. In which process is the gas receiving heat? AB. QAB. That's it. But keep in mind, when we write this QBC, it has to be the amount of heat lost. When we calculate it using formula, the formula that we have are generally for heat gained by the gas, heat received by the gas. So better make sure that we are taking modulus of that quantity. So let's try to get expressions for QBC and QAB. First of all, QAB. AB is what kind of process? Isothermal. So how do we get heat for isothermal process? Delta U is 0. So W itself, isothermal process, right? Delta U is 0. So Q and W will be same. For isothermal process, work done was nRT ln V final by V initial. Q will also be same. nR, the temperature at which that process was working was T1 ln V final by V initial. V final is V2 divided by V1, right? For isothermal process, this will be expression for QAB. I think that's fine. So maybe we can substitute V2 by V1. Well, we'll got the expression. We'll compare the expressions later on. Also, let's try to get QBC. BC process is isochoric. Isochoric process, work done will be 0. So Q will be delta U. Delta U for isochoric is NCV delta T. So yeah, correct. Q will also be NCV delta T. But CV for ideal gas, monoatomic gas will be FR by 2, 3R by 2. So 3 by 2 NR. And then what shall be this delta T? Final temperature minus initial. T2 minus T1. T2 minus T1. So what do we get here? 3 by 2 NR. I think if we want to calculate this, better we get in terms of T1 rather than both, right? Can we convert T2 in terms of T1? We got some conversion, T2 in terms of T1. So T2 can be written as T1 into V1 by V2 power 2 by 3. T2 is T1 into V1 by V2 to the power 2 by 3 minus T1. So what do we get? We can take T1 out. 3 by 2 nRT1 times V1 by V2 times 2 by 3 minus 1. So what do we get? We got this expression for QBC, but we know they are talking about for given value of V2 by V1, eta does not depend. They are not asking us values. They're just asking whether it depends or not. Let's just get the expression. So eta equals 1 minus mod of QBC. Well, mod of QBC, we have to take modulus, but we know QBC, we calculated this as heat gained by gas, so heat lost. Basically, if this quantity is negative, to take modulus, we have to take negative of this. So take 1 minus, I'll write 3 by 2 nRT1 into 1 minus V1 by V2 power 2 by 3, all that divided by QAB. QAB is nRT1 ln V2 by V1. So we get nRT1 cancelled. Eta equals 1 minus 3 by 2 1 minus V1 by V2 power 2 by 3, all that divided by ln of V2 by V1. For a given value of V2 by V1, eta does not depend on temperature of the isothermal process. Yeah, it doesn't depend on T1, right? Option B is also correct. They didn't ask value, we don't have to substitute anything, just, does it depend or not? Yeah, A is correct, C is correct, A, B, C will be the answer. D is wrong.
Yeah.
Hello. So today basically we are going to discuss that JEE Advanced paper 1 question number 16. Okay. So in that question it is given that to find the moment of inertia of the different type of structure of the rods. Okay. So if moment of inertia of rod about an axis at an angle theta at the center So it will be like I equal to 1 by 3 ml square sine square theta. So we will go from the one by one from the structures. So first one is, we will consider the P diagram. It is given like this. So it is making an angle 45 degree with the center. So I can say take this one as rod 1, this one as the rod 2. Now, so I will count, I total will be I1 plus I2, that will be 1 by 3 ml square sine square 45 plus 1 by 3 ml square sine square 45. So I am getting 2 by 3 ml square sine square 45 is 1 by root 2 square, that will be 2 by 3 ml square 1 by 2. So I am getting the one that is ml square by 3. So basically P matches with 5. P matches with 5. Now second one, Q will be the diagram will be given like this. Now this is given 60 degree angle, this is given 60 degree angle. Now if this is L, this is L, this is L, can I take this perpendicular distance for this rod 3 will be root 3L by 2. Now, so my I total will be, let's take this one is rod 1, this one is rod 2. So I1 plus I2 plus I3. So this one will be 1 by 3 ml square sine square 60 plus 1 by 3 ml square sine square 60 plus I3 will be ml square. So here m multiplied with that distance. Distance will be root 3L by 2 whole square. So if we will solve, here we are getting 2 by 3 ml square sine square 60 is 3 by 4 plus 3 ml square by 4. So final answers we are getting, that will be 5 by 4. 3 will get cancelled. 2 by 4 is 1 by 2 plus 3 by 4. So we are getting 5 by 4 ml square. So this one is the I total for the Q diagram. So Q matches with 1. Now we will do the R and S. Now R diagram will be given like this. Then now here 4 rods are there. R1, I can take R2, I can take R3 and R4. So I total here will be 4 into I, directly I am writing 4 into I1, that will be 4 1 by 3 ml square sine square 45. Done? Because these angles are given 90, 90, this is 9, total 90, so this one will be 45, this one will be 45. So it will be 4 into 1 by 3 ml square sine square 45 is directly I am writing 1 by 2. Directly I am writing 1 by 2. So this one I am getting I total will be 2 by 3 ml square. Directly I am writing 2 by 3 ml square. So R1 matches with 4. R1 matches with 4. Now S. S diagram is given by rods are like this, arranged like this. See, this one is rod 1, this one is rod 2. This angle is given 30 degree. This one is given 30 degree. Done? Now I total will be, I will write I1 plus I2. So again I am writing 1 by 3 ml square sine square 30 plus 1 by 3 ml square sine square 30. Done? So this one will be 2 by 3 ml square sine square 30 is 1 by 4. So I am getting 1 by 6 ml square. 1 by 6 ml square. So S1 is matches with option number 2. So I can write the correct option is option number A. That will be P matches with 5. P matches with 5. Q matches with 1. R matches with 4. And S matches with 2. This one. Done. Thank you.
Prem sir?
Yeah.
Okay. Question number 6, paper 1. It says a particle is thrown with a speed v from a point O at an angle theta with the horizontal plane such that it passes through some point P which is at a height of 1 meter at a horizontal distance of 5 meter from O. So 5 comma 1, acceleration g downward, and you have to pick the correct options out of the following. So I'll just start with x, y equations. So initial velocity, and for y, gt square, and write tan theta as y plus half gt square by x. So that gives me gt square is 2 times x tan theta minus y, and v I can write as x by cos theta into t, and the y component of speed at any later instant is u sin theta minus gt. Right. So u sin theta minus gt in terms of x can write as x tan theta by t minus gt, or x tan theta minus gt square by t. So I'm just going to use this to check the sign of vy. If it's negative, then you know it's after reaching maximum height. If it is positive, this is before reaching maximum height. So for the different cases given, theta equal to 45. If you put theta equal to 45, you'll get 5 minus 1, 4. So gt square is 8, or t square is 8 by g, or t is 2 times root of 2 by g. Substitute that here, 5 cos 45, 1 by root 2, and then this is 2 root 2 root g. So 5 by 2 root of g. That's option A. Option A is correct. And now to check whether it reaches the point after it reaches the maximum height, just check the y component of velocity. X tan theta is 5, gt square is 8. 5 minus 8 will be, so for theta equal to 45, case Vy will be 5 minus 8 by t. I only need to check the sign. This is less than 0, means it's going down, so maximum height has already been reached. So option A and option B are correct. To check for the C and D options, if you put theta equal to 30 degrees in this, you'll get gt square is 2 times 5 by root 3 minus 1. Repeat here, you'll get 5 by root 3 minus 10 by root 3 minus 2 by t. It is 2 minus 5 by 5 by root 3 by t. Again, just looking for the sign. 5 by root 3 approximately 1.7. This will be more than 2. So Vy will again be negative. That means here also the maximum height has already been reached. The particle is going downward. So option C is not correct. And option D, if you put tan theta equal to 1 by 5, you will get t equal to 0, which is not an acceptable solution. So A and B are the only correct options for this.
एक इसमें लगा दो फिर आवाज नहीं
Yes, why?
है
1 second, sir.
Okay. Hello guys. So we are done with paper 1 solutions. Probably you enjoyed it, and here we have a crisp and brief review of what happened in the first paper. Okay. So okay sir. So let's go through all the questions and think like as a student how they'll feel about these questions. Okay, let's think like from first question we'll go. So by looking at first question, what a student should do, sir, like how they have to approach.
First question is based on rolling and kinematics, and similar question asked in the previous year, that one disk and another disk rolling on that. Similar question is this one, and I think most of
the students would have done it, right? Okay. So what about
they were not easy moderate questions, but similar questions we have practice also in the classes, and students
so we can
must complete it.
can we say like if they are practiced well with the previous year question number 1 they could have done it, right? So only rolling and kinematics are
Kinematics.
okay. So what about second one?
Second one is slightly tough.
Yeah.
In this question, one coil is present inside the bigger coil.
Yes.
And so it is not actually tough. It is more than 2 steps required. Suppose we first you find mutual inductance of 2 coils, find also relation between their currents, and then find equivalent inductance, and after that you solve the frequency.
Yes. But sir, don't you think it's more involved for a student, like at that point, at that pressure, can they handle this just like that?
It is tough question, but they can handle. Good students practice more questions. Very like this type of questions. Then they have attempted.
So what is the trickiest part in this, sir? In this problem, the trickiest part?
2 points. First, to find mutual inductance.
Okay.
And second point, find relation between their currents.
Okay.
That is a tricky point.
Yes.
How to find relation between their currents between 2 coils.
Okay, they can't just assume some like standard relations and do it. They have to literally apply what they have learned as a principles, right? So what about third question, sir?
Third question is very interesting question, because this question, similar question asked in advance many years before.
Okay.
Same question. It is based on rolling and energy conservation, and exactly same question asked.
Yes. So meaning
In
they
the
can easily
many
secure
years
marks.
I think,
Easily they can get right. Okay. So basically it is rigid body with energy conservation.
Energy
right?
conservation.
Okay. So what is this fourth question? It looks graphical. Is it on tougher side, easier side?
It can easy. Okay. Side, because in this question only we need focal length of the lens.
Okay.
In the medium, and after that we relation find the power.
Okay.
And we draw the graph. Very simple case.
Meaning then it is like a easy problem to
Easy problem.
fetch marks. Yes.
Easy problem.
Okay. So at least something they are getting easy. Yeah. So then next one, sir. Fifth question. So I think fifth question is also on easy side, just
Easy side. It is harmonic
manipulation.
question and more theory based question. It is
Yes.
also easy side.
So they can easily do it. What about sixth, sir?
6 is it is projectile question based on equation of trajectory. It is also easy question, not tough.
So now the students who are in first year, right? If they are excited to solve some questions in the advance, they can try this,
They
right?
can try this.
Yeah.
They enjoy it.
They enjoy, yes. So next, so seventh question, sir.
It is thermodynamics question
Yeah.
based on efficiency of the cyclic process.
Yeah.
It is moderate question.
So
TG side moderate question.
I was hearing our students, right? They were saying like in IRPs, right? What we conduct as revision, right?
Similar questions are
Similar
given.
questions
Similar
are there.
questions
They
are
are saying
given.
Yeah. So then the next question, sir. What do you think about the next question? Eighth question.
It is electromagnetic wave question, and it is also very easy question.
Okay.
And always electromagnetic questions, electromagnetic wave, one question come from that, and always easy side.
So dear students, those who are watching, like first year students, you have to get all these cues from us. So first year, you know that like which chapters will have what weightage and all. So anyways, your seniors have written the examination. When you are doing, right, you have to take all these simple chapters and master it. Okay. So sir, next question, sir. Question 9.
Question 8 is based on fluid and SHA. Both.
Okay.
It is moderate question.
Right. So fluids, they should know basic ideas of fluids.
Basic idea only.
And
SHM.
SHM, right? Okay. So next question, sir. Ninth one. Ninth one done. 10th question.
Then based on Carnot engine.
Again thermodynamics.
Efficiency.
Okay. So we have efficiency.
It is moderate question.
Moderate question.
Moderate question.
Okay. Sir, what about 11th?
11th is also based thermodynamics question.
Thermodynamics only. Okay.
But it is moderate question.
Yes, moderate question. Then 12th question, sir. How about 12th?
Magnetism.
Magnetism.
Actually, it is based on integration.
Okay.
And, it also moderate question because we consider ring and find magnetic field, and after that.
So those students who find integration is tough, right? For them, this you recommend this problem, or you just they have to just skip this problem.
No, not tough question. They can practice this question, and in our classes we have practiced many this type of questions in the class.
Okay.
And I think that most of the students attempted it.
Okay. So then 13th question.
13th question very easy question. It is based sound wave and interference of wave. It is only on based on part difference.
Yes.
And
So
only
I
part
think
difference, and I think it is easiest question in the paper.
so. I think like everybody should have secured at least this marks, right?
This mark.
Yes. So 13th done. What about 14th question, sir?
14 is geometrical optics and wave optics based question, and it is only theoretical.
Only
No
theory.
need calculation, just informative. If you know information, then you correct it.
Yes. So
Only
meaning
informative, and NCRT books and our class notes also available in that.
so both the match the following doesn't have any calculation easier side.
13, 14 both are easy side.
Yes. So what about 15th, sir?
15 EMI question need you can moderate question.
Moderate question.
Moderate question.
So they should know how to use our EMI flux calculation, right?
Right.
Like EMF generation. So what about 16th, sir?
16 moment of inertia. It is also easy question, not tough.
Yes. Our do you recommend our first year students to try this one?
Yeah, they can attempt.
They can
And
attempt,
the very
right?
interesting point is that
Yes.
in the whole paper,
Yeah.
rotation,
Yes.
RVD, chapter,
Yes. Yeah.
and thermodynamics,
Yes.
many questions come.
So meaning after the entire paper, if somebody has to say like which chapters are high weightage, so which chapters are RBD,
In this paper,
In
RVD
this
and
paper,
thermodynamics,
thermodynamics, then
and SHM also. fluid
SHM and EMI.
EMI is also.
Right? So
EMI
if
is
these
also.
4 chapters, if they master this paper, they can solve. It's a good training for them. So and we'll see now how second paper goes. Okay.
We will discuss again second
Yeah.
paper.
So stay tuned, viewers, and we'll be back. Thank you.
Thank you.
Yeah. Good evening, students. We're going to start physics paper 2, and I'm starting with the question 1. So question 1 is basically based on finding basically finding a drift velocity in a conductor. As we can say that the metal wire, a lot of information is given in the question. Let me say cross section area of a conductor is given is like a 0.5 times of millimeter square, 0.5 times of 10 raised to minus 6 meter square. Let me convert it to SI unit. Yeah, and the length of the conductor is given as 100 meters, and battery of EMF 2 volt, and its internal resistance is given as 1 ohm. And yeah, there is a wire is given, as we know that. And what is the resistance of the wire? It is rho L upon A. We are very aware of that. Rho stands for the resistance, but the question given is in the form of a conductivity. So inverse of that, L divided by sigma times of A. If I substitute the values of all the values over here, the conductivity value provided, how much is that? Conductivity of the wire is 6.35 times 10 raised to 3. Sorry, yeah, conductivity. Next, if I substitute all the values, 100 upon 6.35 into 10 raised to 3 into cross section area, 0.5 times of 10 raised to minus 6, that sums up to 1 ohm. That's equals to 1 ohm. Now let us find what is the current through the conductor. Electric current through the conductor from Ohm's law, we can say that V upon R, R plus R, internal resistance must be considered, and EMF is given as, I have mentioned it as a E, and 2 upon 1 plus 1, and that adds up to 1 ampere. Yes. Now we are closing, we are becoming closer to the answer. We need the drift velocity of the electrons that are passing inside the conductor. And how can we do that? We know that I is equals to N times of E A V suffix D. So here N represents number of electrons per volume, and E is the charge of electron, and A is the cross section area, and VD is the drift velocity. Now how are we going to find first? Let me find the number density. N can be written as number density, number of atoms present in a conductor divided by the volume of the conductor. And once again, the number of electrons present inside the conductor can be represented as, it depends on the mole value. We are given the number of moles also. Now I can write this one, N is equals to mass of the conductor divided by the mass divided by molecular mass multiplied by Avogadro number times divided by volume. Once again, N is equals to, mass can be represented as here density into volume, density rho into volume V times of capital M and Avogadro number A again upon volume gets cancelled. So the number density, number of electrons present per unit volume, can be represented as density times upon molecular mass into Avogadro number, which gives rise to, if I substitute the value, which gives rise to total, it sums up to 6 times of 10 raised to 28. 6 times of 10 raised to 28. Now the actual question is to find the drift velocity, and the drift velocity is current I divided by number density, charge of electron into the cross section area. And if I substitute all that value, we come to know the current is 1 ampere divided by number density is 6 into 10 raised to 28, charge of electron 1.6 into 10 raised to minus 18 minus 19 into cross section area 0.5 into 10 raised to minus 6. Yes. what does it add up to? Drift velocity, which adds up to approximately 0.208 times 10 raised to minus 3 meter upon second. Now, but the question was asking in terms of millimeter per second. Now 10 raised to minus 3 meters become millimeter, 0.208 millimeter per second. Yes, and we can conclude from that this is option C is matching for that. Right. Now we'll see the second question. Is it paused? Yes. Yeah. Welcome again. We'll see question number 2. And what is it asking for? A nuclear reactor starts producing a radioactive nuclei X from time t is equal to 0 at a constant rate of alpha per second. So production rate is given here. Production rate is alpha. And each decay of X produces energy of E naught. So in each decay, energy in each decay is E naught. Now, which is utilized to heat a liquid of mass M, and specific heat of liquid is given as S, assuming no heat loss from the liquid. And so there is no loss in the sense that whatever the energy is released in the reaction totally converted into heat energy to raise the temperature of the body continuously. And taking lambda as the decay constant of X, the rate of increase in the temperature of the liquid. As the question is concluding that there is no losses of energy, the liquid is continuously gaining the energy coming from the reaction, so temperature must be increasing continuously. And now at what rate is it increasing? That is the question for us. Now first let us see the rate of change of number of nucleus. The rate of change of number of nuclei. We can say that it is a production rate minus the rate of decay. So how many X elements are being producing, and in that produced X elements it's been decaying into some other way. By that energy is liberated and absorbed by the water. Now this is number of nuclei decaying per second is given as production rate is given as alpha minus, and decay rate is, we can represent decay constant multiplied by the number of nucleus present at that instant. Now let us do the math. dn upon lambda alpha minus lambda n is to dt. Let me take the integral part of it, and what does it sums up to? And okay, let me take the limits over here. Number of nucleons are changing, produced number of nucleons are produced per second would be 0 to n from time 0 to t. Now ln of alpha minus lambda times of n divided by minus lambda 0 to n, that is equal to t. Now if I substitute the limits, I would be getting, let me send minus lambda to the other side, and this would give rise to me, if I substitute the limits, lambda alpha minus lambda n upon lambda, and that is equals to minus lambda times of t, and 1 minus lambda n by alpha tends to e to the power minus lambda times of t, and 1 lambda n by alpha is equals to e to the power 1 1 minus e to the power minus lambda times of t. And we need number of nucleons are present at that instant. And what's happening here? Alpha by lambda times of 1 minus e to the power minus lambda t. And n is a number of nucleons present at the instant of time t. At that instant of time t. Now, but what is the question he's been asking here is like the rate of rise in temperature. The rate of rise in temperature. And how do we do that? Can I erase this? Yeah. So let me take a space over here from this side. The rate of energy liberated or heat energy. Heat energy produced. It's a dq by dt. That is equals to it can be dk, rate of decay multiplied by the energy liberated. R is the rate of decay. Okay, let me say the rate of decay. R can be represented lambda times of n. Now if I can substitute and the heat energy Q can be represented as mst. Now if I substitute all the values into the given equation, I can write d by dt times of m times of s into capital T is equals to lambda times of n into E naught. Furthermore, lambda times of n value we have derived over here, 1 minus e to the power minus lambda times of t into E naught. Lambda that get cancelled out, but we are interested only in finding the rate of rise in the temperature. So d capital T by d small t, and capital T by d times of small t. So mass multiplied by specific heat if I am sending on the other side, lambda E naught divided by m times of s into 1 minus e to the power minus lambda times of t. Yes, this is our required answer, and this one is option A, first option we got. Thank you.
So we are doing paper 2 question number 10. So we have two thin wires. Wire 1's diameter is given and wire 2's diameter is unknown, that is small d. Now we have been given two tables, all right. So first of all we'll check whether we have zero error in this question or not. So for wire 1, the main scale reading is given as 0.5. So we know that total reading is equal to main scale reading plus least count into circular scale reading, right? Now what is least count? Least count is equal to pitch by number of circular scale division. Pitch in this question is given as you can show me the question. So pitch is given as 0.5 mm and circular scale division is given as 100. So when you solve this, you'll get 1 by 200 mm. So total reading in first question is given as 6.5 or 0.650. So 0.650 mm is given as the reading value, equals to main scale is given as 0.5 mm plus least count we just found out 1 by 200 and multiplied by circular scale division, that is equals to 42. So if both of them comes out to be equal, we'll say that there is no zero error. So let's check. So the RHS value comes out to be upon calculation 0.71. all right. So you see that this value is coming more than this value, all right. So that means there is a zero error and that is positive because actual reading is lesser than this. So we have a positive zero error. So zero error is equal to 0.71 minus 0.65. So you'll get 0.06. All right. Yeah, you'll get 0.06 in terms of mm. Now we'll check for wire number 2. So for wire 2, total reading, question please. So for wire 2, total reading becomes equals to 1.5. The value is given as 1.5 into 1 upon 200 multiplied by 95. Okay, 95 is the circular scale reading. So when you simplify this, the value which you'll get is 1.975. all right. Now this is the value with zero error, so we'll subtract this much from here. So true reading, or you can say actual reading, so actual reading AR becomes 1.975 mm minus 0.06 mm. So you'll get the value as 1.915 mm. So in terms of micrometer, you'll get 1915 micrometer. Okay, question please. So I think they asked us the value in micrometer. Yes. So answer becomes 1915 micrometer. Thank you.
Let me know when started. Started. Okay. So, paper 2, question number 11, physics. In a single slit diffraction experiment, a slit of width 0.016 plus minus 0.002 mm is used to measure the wavelength of a monochromatic light source. In the diffraction pattern, the angular distance between the central maximum and the first minimum is measured to be 2 degree plus minus 40 arc minutes, that single dash. The value of the fractional error in the measurement of wavelength is. So they are asking fractional error in the measurement of wavelength. If we know the slit width and if we know the angular distance between the central maximum and first minimum, how do we get that wavelength? We have the formula. I'll just treat it as a formula now. So it was lambda equals a sine theta, right? So if we know the slit width A and if we know the angular distance between the central maximum and first minimum, then using them we can get the wavelength of the light. Lambda equals a sine theta. Now from here we have to evaluate the fractional error in measurement of wavelength. So for fractional error in measurement of wavelength, we have to go with error analysis, right? I'll go with differentiation, so that d lambda will be that error in measurement of lambda, dA will be error in measurement of it, d theta will be error in measurement of theta. So let's differentiate both sides, let's say with respect to theta. So d lambda by d theta on left side, right side it will be product rule. So differentiation of right side with respect to theta, a cos theta plus differentiation of the other part. So sine theta remains as it is, it will be d theta dA by d theta, sine theta into dA by d theta. So we could get an expression for d lambda, which is supposed to be error in measurement of wavelength. It will be a cos theta and multiply d theta with both the terms, d theta plus sine theta times dA. So we get this expression for d lambda. This is the error, but we want to find the fractional error. So fractional error will be the error value d lambda divided by actual value, right? So we get d lambda by lambda as the fractional error, and that we have to divide by lambda. Lambda was a sine theta, so I'll write a cos theta d theta plus sine theta into dA, all that divided by a sine theta. So what do we get for fractional error? A gets cancelled, cos by sine is cot theta, this times d theta plus sine theta by sine theta gets cancelled, dA divided by a. This will be expression for fractional error d lambda by lambda. The question is now just evaluating it. So the given data, what are the values of theta, a and dA? We know dA value is given as 0.002 mm. They have given that error in A. A itself is 0.016. Cot theta, well, we have to evaluate that. D theta is 40 arc minutes. That's the error in measurement of theta. And cot theta, well, we have to evaluate that. They have given sine 2 degree. We have to get cot 2 degree. I'll use that triangle method. So maybe I could draw the triangle here. If this angle is theta, which is 2 degree, then sine 2 degree they have given as 0.035. So opposite side is 0.035. Hypotenuse will be 1 unit, and then the adjacent side will be root of 1 minus 0.035 square. So cot theta here will be adjacent side by opposite side divided by opposite side. So this divided by 0.035. We can substitute that for cot theta, and then d theta will be 2 by 3 degrees, right? So we have to convert that in radian as well. So let's take care of all these things. I'll start writing the expression. Fractional error in measurement of wavelength, cot theta first of all has to be root of 1 minus 0.035 squared. This is adjacent side by opposite side is 0.035. This is just cot theta into d theta. D theta is 40 arc minutes. 60 arc minutes would have been 1 degree. So 40 arc minutes is 2/3 of a degree. 2 by 3 degrees converted to radians. So into pi by 180. Pi is 22 by 7 and 180 is also there in denominator. This is just d theta, cot theta into d theta, plus dA by A. dA value is given as error in A 0.002 divided by A is 0.016. Now when you calculate this 0.002, so this is almost 2 divided by 16, so 1 by 8. So this is 1:8 ratio. Well, when we do this calculation, 22 into 2, 44. This is 35 by 1000. 1000 goes to numerator. The number becomes much bigger, right? 1000 by 180. It still becomes some significant number. So this root of 1 minus 0.035 squared could be just approximated as 1. I could write this as 2 into 22. 2 into 22 divided by 3 into 7 into 180. And what I have to also write is 35 by 1000. All that plus 1 by 8. So rest of the task is just calculation. 1 by 8 is 0.125. Well, and when you do this calculations, you'll get somewhere around 0.33 something, right? So when we do this calculation, the overall number will be 0.45. So this was almost 0.34 almost, right? So overall number will be 0.45. So the fractional error in the measurement of wavelength will be 0.45. Now I'm not going to do this calculation. You can do it. The number is coming out to be, addition of both of them is almost 0.45. Next is question number 12. As shown in the figure, a ray AB of unpolarized light enters from water of refractive index 4 by 3 into a medium of refractive index 4 by root 3 after passing through a glass plate of refractive index 1.5 and a layer of water. So they have given water layer again 4 by 3 itself. At a particular incident angle I, the reflected ray CD is polarized in the direction as shown in the figure. The value of I is, so reflected ray is polarized. Maybe we have to use Brewster's ideas, right? So when light goes from one medium to another, it doesn't fully go into second medium. Part of it gets reflected as well. So when the angle of incidence is equal to Brewster's angle, in such case the reflected light is totally plane polarized. So at that third incidence, first incidence was from water to glass, second from glass to water, third will be from water to that new medium P as well again. So that third incidence I'm saying, suppose the angle of incidence there is some I. By the way, how much is that I? If there are number of interfaces parallel to each other and then first medium and third medium are same, then angle into which it goes, the light goes parallel to the first medium again, to the light in first medium itself again. So let's say this is water, then there is this glass layer, then there is again water, and then there is this next medium. So first medium, light was incident at angle of incidence I, then it goes into glass, but when it again goes into water, if the surfaces are parallel, we know the light comes out parallel to the incident ray, so like this, right? So again here the angle of incidence will be I itself. Now with that angle of incidence, the light is getting reflected such that the reflected light is plane polarized from here itself. So here onwards, it will be just plane polarized. That is possible if angle of incidence is Brewster's angle. That's basically when the angle of refraction here is such that the refracted ray and the reflected ray, both of them are perpendicular to each other. So this angle of reflection should be I itself again. So we get this as I, that as R, and then this reflected ray will be plane polarized. So we have to write conditions for that. When a total angle on the right, to the right of this line will be 180 degree. So this was 90. I plus R should be 90. R should be 90 minus I. And then we can write the equation for Snell's law between water and that medium P. So for water, refractive index was 4 by 3 sin I. And for P, the refractive index is 4 by root 3 sine of, this is 90 minus I. That's the angle of refraction into medium P. We get 4 cancelled. This root 3. So there will be root 3 in denominator. 1 by root 3 sine I equals sine 90 minus I is cos I. So we get tan I equals root 3. I has to be equal to 60 degree. That's it. The angle of incidence from the water side. This angle and this angle are same. So here itself the angle of incidence should be 60 degree. Yes. Started? Okay. So now question number 14, paper 2. Question number 14. In a new system of units, the units of mass, length, time and current are 5 kg, 5 meter, 5 seconds and 5 ampere respectively. So they have changed the units. If mu naught and epsilon naught are permeability and permittivity of free space respectively, then in this new system of units, the magnitude of 1 SI unit of root of mu naught by epsilon naught is. Okay. I think we can use speed of light. Mu naught and epsilon naught is dealt with, right? So speed of light is root of 1 by mu naught epsilon naught. We want to get mu naught by epsilon naught. I'll just rearrange. I'll write root of mu naught epsilon naught equals 1 by C. And then we can divide epsilon naught on both sides. So 1 by epsilon naught here, 1 by epsilon naught there. This epsilon naught by epsilon naught will get root mu naught by epsilon naught on left, and that will be 1 by C epsilon naught on right. So what will be units of this quantity? Root of mu naught by epsilon naught. I could write the units as 1 by C. C was the speed of light. Speed of light will be, if we write dimensional formula, L1T minus 1. If we write units, let's write units. So C is meter per second. What about epsilon naught? To get epsilon naught, we could recall that Coulomb's law. Force is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. So we get epsilon naught from there goes in numerator, Newton goes in denominator. So Coulomb square divided by Newton meter square. Coulomb is not SI unit. Ampere is, right? So we have to write Coulomb square as, current was charge per unit time. So charge is current into time. Ampere square second square. This is epsilon naught. I'll use that for epsilon naught. Ampere square second square divided by Newton meter square. I'll take denominators, numerator to numerator. So we get this. Now this aside, I could write root of mu naught by epsilon naught. I shouldn't have equated here. Here I'm just writing units. So root of mu naught by epsilon naught, the units will be, I'll take denominator seconds, well, I could cancel it here itself. We get Newton meter square. Again, Newton is not the fundamental unit, right? So we'll convert it into kilogram meter per second square into meter square divided by meter ampere square into second. So what do we get overall units? This will be kilogram, this meter cancel, meter square divided by ampere square second cube. So SI unit of this quantity, root of mu naught by epsilon naught, will be kilogram meter square per ampere square second cube, right? Is it visible? Second cube. So we get this expression. Now let's think about the new set of units. So in new set of units, dimensional formula will still be same. So mass to the power 1, length to the power 2, current to the power minus 2, and time to the power minus 3. Dimensional formula will still be same, but then we'll be using new set of units. So I'll call that new units as kg dash, meter dash, ampere dash, and second dash. So in new set of units, I could say in new system, we could write units of root of mu naught by epsilon naught as kg dash to the power 1, mass to the power 1, kg dash into meter dash squared divided by ampere dash squared second dash cube. We get this, and then we have to compare that with SI units. SI units was kg meter square per ampere square second cube. So let's use the conversion factors now. 1 kg dash 1 meter dash squared divided by 1 ampere dash squared and 1 second dash cube can also be written as 1 kg dash is, they have given every conversion factor is 5, right? New values are 5 times of old value. So new 1 kg dash is 5 kg to the power 1, that's it. 1 meter dash, so that's 5 meter whole square divided by 1 ampere dash, 1 ampere square, and 1 second dash, so 1 second cube. What do we get here? 5 into 5 squared, ampere squared. So this was 5 ampere, right? 1 ampere dash is 5 ampere, so 5 squared again, and then 1 second. So 1 second dash gets converted to 5 seconds. 5 seconds cube is 5 cube, and then the rest kg meter square per ampere square second cube. Now 5 squared cancel. 5 by 5 is 1 by 25. 1 by 25 kg meter square per ampere square second cube is new 1 unit of that quantity, root mu naught by epsilon naught. So this was SI unit. 1 SI unit is how many times the new unit? So 1 new unit, U I could call it. So SI unit, 1 SI unit is 25 times of new units. So the answer will be 25 times. Then in this new system of units, the magnitude of 1 SI unit, they are asking 1 SI unit, so we have multiplied 25 on another side. So the answer will be 25.
So if it is done, tell me. Everyone, so we have question number 4, and I hope question number 4 is pretty interesting, and we'll see how it goes. We have a particle of mass m with angular momentum small l is moving in a circular orbit of radius r0 under the influence of an attractive force which is given by vector f minus k by r squared r cap, keeping its angular momentum unchanged if the particle is displaced radially by a small distance dr, much smaller than r0, due to which its radial distance varies periodically, it seems. Now the question is the corresponding time period, that variation of radial distance, right? Its corresponding time period is what they are asking. Okay, so it's pretty good problem, and it involves the ideas of Newton's laws of motion, circular motion, and little bit of approximations. So let's try and solve this. Okay, so we have this idea that if there is a particle which is moving in a circular orbit of radius r0, let's say this particle has mass m and this is moving with certain velocity. If it is moving with certain velocity, definitely we can say that it has some angular momentum around this path, right? So angular momentum is given, L is given, that's the given symbol. So it is m, v and r0. This would be the angular momentum. But what we'll do is we'll just write this as m times velocity as omega, the angular speed with which it is moving in this circular path, omega r. So the radius is r0, right? So we'll write it as L equals m omega r0 squared. Let's keep this one as first equation. Okay. Now we know that if this is maintaining the circular path, there is a force, and according to our given logic, this force F, right, that is given as k by r squared. It is in the radially inward direction. Since radially inward direction, we are showing in the diagram, no need to write here. And this force is helping it to move in a circular path, right? So k by r squared should manifest as centripetal force. So m omega squared r would be the centripetal force, correct? Now once we get this logic, we'll just see that if this is the given configuration, then k by r0 squared is equal to m omega squared r0. That would be the initial condition. Let's keep that one as equation 2, because this is our initial condition. It was moving peacefully like this with r0 radius, and it was maintaining that circular path. So from this configuration, we are going to disturb it. Okay, we'll give a small displacement dr in a radial direction, let's say, and that dr is going to be really small. According to the question, the dr is much smaller than r0. Okay, so we are going to use that and see what changes can happen. Suppose if we write here the small dr here, meaning from here to here we are displacing, and now it is going to move in a bigger radius like this. But according to the given configuration, they are saying that this radial distance is going to change periodically. So we'll see like what happens here. Now because of this increment, right, so this changes in the length is dr. So let's see like what will be the new force. The new force would be k by r plus dr the whole square. This is a new force. This will be the new force. But this new force, if I name this one as say inward force, let me now call that one as f dash. F dash would be the inward force. Okay. Suppose if this is inward force f dash, we could have said this f dash acting like centripetal force if it is just maintaining the circular path. But we also know this, it is not just maintaining the circular path, it is moving say from its original position, it is going in a wobbling type of motion where it is just increasing the radius, decreasing the radius. That's how it is moving, right? So because of that, we can't say that this force is exactly equal to centripetal force, because we would have said this way, this is equal to m nu omega square times of r plus dr. We would have written this if it is moving in a circular path, right? But it's given that it is not going to maintain new circular path, right? It is going to change the radius. We cannot make this as equal. So if we write it as equal, it is going to be wrong. So we'll say like, okay, so this is not equal. It will be some difference. So it won't be exactly cancelling up. So there will be a net force here. There will be a net unbalanced force here. So this force minus this force would be some net force. Got it? So meaning you have displaced it with R increased, right? So this minus this would be the net force acting on our system. Now we'll see what will happen with that. Okay. Now with this logic in place, we can write the net force being equal to, I'll just do a little bit of simplification and call this small r as R naught. This is R naught, right? So we can just change this as K by R naught squared, and I lift this one and write it as 1 plus dr by r whole squared. Okay, dr by r whole squared minus, we have m omega dash. Omega dash is a new value of angular speed, right? So we can write that one as omega plus d omega. If there are any changes in omega, we are going to witness that squared times of r plus dr. So I hope you can easily observe this, r plus dr. That is what we have as an equation, correct? Now we have to little bit handle like what happens with d omega. We have small l, which is given as m v r naught, which is m omega r naught squared. From this we can see that changes happening to angular momentum is 0, because from the given data angular momentum we have to keep it constant. So we'll keep that as constant and we'll differentiate it. So that would be 0, and we'll see that variation in L in terms of omega and r naught. So this goes as omega 2r dr plus r square d omega. This is what we have. Then we will just simplify this. So see here, wherever we have r, right, I'll write it as r naught. Just for convention, we stick to r naught configuration. So dl is this. So dl is 0. So we can solve for, say, d omega. So omega 2r dr being equal to r square d omega. So negative sign here. So d omega would be equal to, see, we are just changing, seeing the changes happening to the omega. The changes happening to the omega is given as minus 2 omega by r dr. Minus 2 omega by r dr. Just cancel omega, sorry, r and r, and just rearrangement, you will get this. D omega is this value. So let's plug this information here and let's check what happens to our expression. So here k by r naught squared and 1 plus dr by r whole power 2 minus m omega plus, in place of d omega, right, I'll be writing this one. So omega minus of 2 omega by r dr, the whole squared into r plus dr. This is what we will have. Please check once. After this, a little bit of simplification again. So we have net force here, which is k by r naught squared. We'll write it as 1 plus dr by r naught whole squared minus m omega squared. Here I am taking omega outside and simplify this. So 1 minus 2 by r dr will have 1 minus 2 by r dr whole power 2 into r plus dr. That's our equation, right? Now observe, once you are done with this, see, till now we did not do any approximations. We did not use this particular condition yet, right? Now we are going to employ this here. I'll be just ensuring that wherever we have r, it is r naught, right? Because about r naught you are giving a small displacement. So this is what we have. So this is given. Here we have this kind of terms. So we'll be using binomial approximation, okay, and simplify this a bit, okay. So as we do this, I'll be erasing this a bit here and rewrite this, okay. So here I'll keep this value as it is because I might need it, right? So I'll just keep this value, and L equals m omega r naught squared. I'll write L equals m omega r naught squared here. Let's simplify this further. So I'll just take some space here. We know that this is a diagram for us. Yeah. Now using that Fnet expression, Fnet is given as, say, k by r naught squared. Using binomial approximation to become 1 plus 2 times of dr by r naught. Then we have minus m omega squared times 1 minus 4 times of dr by r naught. Then we'll have r naught plus dr. This is it here. So I think till this point you should be careful. From here on, this mathematical manipulation, you will get it. Okay. So from this point, we'll have, say, when you multiply this, right, we'll have k by r naught squared plus 2k by r naught cube here, dr here, minus m omega squared r naught, m omega squared r naught, then m omega squared plus into dr, right? So that I will write m omega squared dr. And when you observe this term, we have 4 times dr by r naught. So we'll write, if you observe, when you multiply dr with dr, so dr square, right, will be negligible when dr by r naught we are considering. So dr squared by r naught is tending to 0. So since we are already using approximation, dr by r naught itself is small. When you have dr square, it is really small. So we are going to ignore that and make it as 0. Okay. So that is what we have. So once we have this, we'll see, like, is there anything to cancel? So we'll have k by r naught squared. This term is same as m omega squared r naught. So this and this getting cancelled out from equation 2. So we have used this equation already now in our system. Now we'll have net force given as 2k by r naught cube minus m omega squared times dr. This is what we have. Now after this, from this we also know this, the net force, right, it is acting more like a restoring force in its nature. So we can write this one as negative of mass times acceleration. This minus just implies that it is like restoring in its nature, right? So we can write this as 2k, same value, 2k by r naught squared, r naught cube minus m omega squared dr, right? So this is what we have. So I'll be sending this mass here to the denominator here, m here and one more m here. So this is gone. So we have acceleration is this value. Let's simplify it further. So we have this quantity. Now you can see that in our options there is nothing like this, right? Meaning you have to be in a position to rethink about expressing in a given terms. So since it's not directly evident, so we'll do a little bit of arrangement. So we had this expression k by r naught squared, right? That is equal to m omega squared r naught. This we already derived it. So from this, and L is equal to m omega squared r, right? M omega r naught squared, because m be r, then we'll write it as m omega r naught squared. Using these two, we can write k in terms of L. K is equal to L squared by m r naught. K is equal to L squared by m r naught. So use this here and you can express this idea. Omega is equal to L by m r naught squared. Here omega squared will have. Just simplify this. Just plug this information here in place of omega, L by m r naught squared here and square that. Okay. And wherever we have k, we'll substitute L squared by m r naught and simplify. As we do that, we'll get acceleration is given by L squared by m squared r naught power 4. L squared m squared r naught power 4 dr. This is what we will get here. Okay. So once we have this entire thing, right, now it is a condition for SHM. This is a condition for SHM. I hope you know that acceleration and small displacement, this part is frequency getting squared. So I'll be erasing that part. We'll write this way. We have acceleration equals frequency, SHM frequency, square times of dr negative. Correct? So SHM frequency, right? That is given as L by m r naught squared. L by m r naught squared. Please check once. So here we have L by m r naught squared whole square. That is SHM frequency squared. So we'll have SHM frequency as L by m r naught squared. Now time period of that so-called repeated motion, the variation in the radius, right? That is given by 2 pi by that SHM frequency. It will set that periodicity, right? So time period will be 2 pi by SHM frequency would be L by m r naught squared. So m r naught squared. This is what we have. L by 2 pi by L m r naught squared. But if you see that options are not in terms of that, so we have to get rid of r naught and express in a different format. So we know that from this r naught can be written as L squared by mk, right? L squared by mk. R naught can be written as L squared by mk, and if you do that, you will get time period is equal to 2 pi L cube, because when you substitute R naught here, you will have L power 4. One of the L is here, so that will cancel and you'll get L cube here. And when you are squaring it, there will be m squared here, and there is one m in the numerator, so there is one m here, and k squared. So there we have. So if you look at the options, 2 pi L cube by mk squared, 2 pi L cube by mk squared. That's our first option, right? So our first option, that would be the correct for this particular question. So everyone, I hope you understood this one. So you can just check out, we have used all these ideas which involves NLM and the ideas of SHM and little bit of approximations. So these are the concepts involved in this problem here. I hope you enjoyed this, and we'll continue this. Thank you.
Yes, sir. Right. Yes. Hello, dear students. JEE 2026 Advanced Paper 2 Physics Advanced Paper 2 question number 7 solution. So this is the diagram. Let us draw the diagram first, then you will understand better way. Right, coordinate system. Suppose here is point A, somewhere here is point P, this is some other point given. Coordinates x comma y. Here you have charge q1, coordinates are a comma b. Here the charge q2 you have. Here you have charge q2, coordinates are ma and mb. That's what they have said. Okay. So what is the data given for us? Potentials are equal, right? Potential at point P due to q1 and due to q2 are equal. So v1 is equal to v2. v1 is equal to v2. v1 point charge, right? kq by r. R means distance between them. I think you know the coordinate geometry. Distance between 2 points. Under root of x2 minus x1 whole square, x minus a whole square plus y minus b whole square. So v1 kq1 by distance under root of x minus a whole square plus y minus b whole square. Potential at P due to q2. This is k into q2 by under root of ma minus x whole square plus mb minus y whole square, the distance. Okay. So under root of ma minus x whole square plus mb minus y whole square. But q2 is equal to m into q1. So q1 gets cancelled, k and k gets cancelled. I think we can square on both sides. M square will come. You can multiply this, cross multiplication. So the equation that you are left with is, this is the equation. So here itself, m square a square plus x square minus 2 max plus m square b square plus y square minus 2mby is equal to, this one. Whole m square you have to multiply. So this will become m square x square plus m square a square minus 2m square ax. Similarly, m square y square plus m square b square minus 2m square by. Okay. So keep this equation like this. So options are given for us. Option A, option B, option C. See for values of m. Okay. So if you substitute option A, m is equal to, what is the equation? 1 second. Let me see the options. For option A, m is equal to -1, they are saying. If you substitute m is equal to -1 here, no? What you get is, equation is 2ax plus 2by is equal to 0, implies ax plus by equal to 0. So option A is correct. Option A is correct. Okay. That is for option A. You have to check m is equal to -1 in this equation, right? There you can check option A, right? So check option B also. Shall we check option B? Now itself we can do that. So in option B, what they say, m is equal to 2. Option B, let us check it. M is equal to 2. So they are asking locus, okay, circle. And for that equation, what you get is, I think, I have to rub off this. Option B, that is for m is equal to, this is the equation you will get. X square plus y square minus 4a by 3x. Okay. Next, minus 4by by 3 equal to 0. So you have to compare this with the standard circle equation, right? So x square minus 2hx plus y square minus 2ky is equal to r square minus h square minus k square, where the center of the circle is nothing but h comma k. This is the equation. So compare this with this equation. Right hand side 0, so this term is 0. So what does it mean? R is equal to under root of h square plus k square, that is the radius. Compare this with this equation. 4ax by 3, so 4a by 3. Observe this one. 2h is equal to 4a by 3 implies h is equal to 2a by 3. Similarly, compare coefficient of y also. K you will get 2b by 3. So the locus is okay, circle with the center, yes, h comma k, 2a by 3, 2b by 3, yes, option B is correct, okay, option B is correct. And option C, check option C also, what did it say? M is equal to minus 2, right? Yes, that also you can check. If you, option C is also correct. Please put M is equal to minus 2. So if you do that, yeah, let us write this here. Yes, I think we can rub it off. Put M is equal to minus 2. Then what happens? Oh yeah, same procedure you have to follow. Then what happens is H will be equal to 2A, K will be equal to 2B. Okay. So the circle of radius, right, R is equal to under root of h square plus a square, that will be 2 under root of a square plus b square. Option D is obviously wrong. Check M is equal to minus 3, last option, that's not correct. So for this one, A, B, C are correct. Now let us go to question number 15. So, question number 15 and 16. Paper 2, yes, here, question number 15 and 16. Okay, right. This question, they have asked, yeah, parallel plate capacitors. Okay, first I will give you side view of the same scenario, right? This is the three-dimensional picture, right? This is how it is. The containers, this is the second one. This length is 2 meters. This is 1 meter. Right. This is 1 meter. This is also 1 meter. This is actually, right, three-dimensional view of the given diagram, 3D view. But in your question, they have only given you the two-dimensional picture. Initially, yes, this is what they said, right. In this only air at time t is equal to 0, right? This is entirely filled with dielectric constant, that is K equal to epsilon r is equal to 15. Yeah, this distance is nothing but, right, that is 2 meters. Okay, this is 1, this is also 1. So area, I think this one. Area of the capacitor, I think this is 1 into 1. So first capacitor, I will call this as C01, I will call this as C02. Initial capacitance. C01 is equal to K epsilon naught A by D means you have to take 2 meters, right? So this is 15 epsilon naught area. 1 into 1. This one, 1 into 1. Okay, that is 1 divided by 2 meters. This is air capacitor. Initially at T is equal to air capacitor. C naught 2 is equal to epsilon naught into 1 by 2. So this and this are parallel. This capacitor are parallel. So initial capacity of the system, I will write C. Yeah, I will write on the top. Right corner, we have to use this result. Initial capacity, yeah, this plus this. So 15 plus 1, 16 by 2. So this becomes 8 epsilon naught. Up to here it is clear. Fine. Now what we have to see is, right. Yeah, I think I can rub off this part. So what's happening is here, you have punched a hole here. Yes, exactly at the bottom, right? So exactly at the bottom, there is a small hole provided. This is the small hole. Okay. So what happens? Liquid level. Yes, I think I have to change bit modifications here. Liquid level changes here, slowly dropping down. Yes, after certain time, something like this is having a level, right? Y. Okay, and here this level is falling at the rate of V1. Okay, and here this level, okay, right, here it is. Let us say it has risen up to, yes, this one will become 2 minus y, yes or no? At a certain time t, yes, at the instant of time t, as it no equation of continuity. This is a broader pipe, this is narrow pipe. A1 V1 is equal to A2 V2, yes. This is nothing but, right, that will be y minus of 2 minus y. Okay. So velocity of flux. So liquid is level is dropping here, liquid level is rising here, right? So here velocity of flux V2. So yeah, here we can write A1 V1 is equal to A2 V2. V1 is nothing but dy by dt, of course with minus sign. Capital A1, this area 1 into 1. So this one area A1 is equal to 1 into 1. V1 is equal to minus dy by dt. A2, area of orifice. Area of orifice they have given. Please look at the question. Area of orifice, root 10 centimeter square into meter square, you can convert 10 power minus 4 meter square. And velocity of flux under root of 2g y, general formula, right? But here it is not y, it is y minus 2 minus y. So under root of 2g into y minus of 2 minus y. Okay. So this will become, yes, under root of 2g. Okay, sorry, y minus of 2 minus y. Yeah, now it is perfect. So yg, that is 2g into 2y minus 2. So 2 into 2 common factor, 2 into 2. 4, root 4 is 2, 2 into root g into y minus 1. Y is variable, right? So that you have to substitute here. So finally left out is 1, that is minus 1 into dy by dt is equal to root 10 into 10 power minus 4 into 2 root g into y minus 1. So bring this down. Dy by root y minus 1 is equal to 2 root g into root 10. So sorry, 2 into root g into root 10 into, yes, let us write here, 10 power minus 4 whole multiplied by dt, right? So what did he say? At t is equal to something like that. Question number 15. At t is equal to 500 second. T is equal to 500. So you have to write this is from 0 to T, and this is, this is 0 to 500 second, and this is 0 to y. Okay. So if you do that, right, and integrate that, what you get is y is equal to 5 by 4. If you do the integration, you will get y is equal to 5 by 4. Okay. Yes. Now we have to use this for solving question number 15. The question number 15 answer, that is 5 by 4, 1.25. Question number 15 answer 1.25. Okay, right. Now let us move on to question number 16. Yeah, initial capacity of system I have told you already. Now at T is equal to, T is equal to 500 second. Yes, I think we can rub off all this part. Right. Yeah, even this also. This is 2. This y is equal to 5 by 4. Here this is 2 minus 5. 2 minus 5 by 4. I think it is 3 by 4, and this will be right. Yes, I think I can rub off this part also. This capacity, this distance is 5 by 4. Now what is happening is, right, this is air capacitor. This is air capacitor, capacity C1. This is dielectric capacitor. This capacity C2. This is C1. This is air capacitor. This capacity, take it as C3. Here this capacity, take it as C4. Okay, take that capacity as C4. Right. So here these two are in series. Okay, series means effective capacity C1 C2 by C1 plus C2. Okay, C1 I will write the data. C1 is equal to epsilon naught into area 1 divided by this distance. How much? If this is 5 by 4, this is 3 by 4. This is 3 by 4. So 4 will come here. 4 epsilon naught by 3. C2 is equal to dielectric K epsilon naught A by D. So K means it is 15. 15 into epsilon naught, area is 1 divided by, this is 5 by 4. 4 will come here. So this is 12 epsilon naught. So effective capacity of these two, yes, I will write this as C dash C1 C2 by C1 plus C2. Okay, keep this aside. Now C3. Yes, let me rub off this part. C3 is nothing but, this is air capacitor. Epsilon naught A by D. Area is 1. Okay. D means it is 5 by 4. So epsilon naught into 1 by 5 by 4. This is 4 epsilon naught by 5. C4. This is dielectric capacitor. K epsilon naught A by D. K means 15 into epsilon naught into 1 divided by 3 by 4. I think this is 20 epsilon naught. These two are also series. Effective capacity, I will take this as C double dash. C3 into C4 by C3 plus C4. Okay. Now this and this, okay, they are in parallel. C dash, C double dash. So final capacity at T is equal to 500, at T is equal to 500 second, capacity, final capacity C dash plus C double dash. If you do that simplification, guys, what you get is CF is equal to 1.69969 epsilon naught. Initial capacity, initial capacity of system, I think, in the previous discussion, initial capacity, this is what you got, okay, 8 epsilon naught. So what is the difference now? I think we can make use of the space. This I think now I can have it off. Right. So the difference is 8 epsilon naught minus 1.969 epsilon naught. This is given as 8 minus n epsilon naught. 8, of course, it is there, that n becomes 1.969. Truncate to decimals, no. So n is truncated 1.97. That is your answer. Good.
Okay. Let's have a look at question 8 from paper 2. One of the more straightforward questions in this paper. This is about a dipole placed in a uniform electric field. The dipole is initially oriented along plus I. The charges are given minus q plus q, and the mass of each of them is m. At t equal to 0, a field is turned on along the plus j direction. X, y. So the dipole will rotate about its center of mass and its equal masses through the center to align along the field. So let's look at the different options. So we'll just write down the angle in this is measured with respect to the x-axis. Theta final is measured with respect to x-axis, and the field is along the y-axis. So this is theta f. Then the angle with the field is pi by 2 minus theta f. Option A says the center of mass of the dipole is deflected towards j in the presence of the field. It's a uniform field, the net force will be 0, so the center of mass will not move. Then we can say the change in kinetic energy is equal to half I omega square. So be equal to minus of delta, you decrease in potential energy. There will be minus of, initially the angle between the field and the dipole is 90 degrees. So the potential energy will be 0. Final will be minus P, which is Q, D, E, and cos of pi by 2 minus theta f. So this will just be Q, E, D, sine theta f is half, is delta k, which is equal to half. Moment of inertia 2 times m. The separation between them is d by 2. So from the center of mass it will be d. From the center of mass it will be d by 2 each. So d square by 4 and omega square. One of these d's cancels.
You get omega square is 4 times QE by MD sine theta F. So in option B, it says theta F is pi by 6, sine 30 is half. So theta F is pi by 6, you get omega square is 2 QE by MD, or omega is under root 2 QE by MD. And then option C says theta F is pi by 3. In that case, the change in kinetic energy will be QED sine pi by 3, which is root 3 by 2. But in the options it says 2 root 3. So that option is also not correct. So far, A wrong, B correct, C is also wrong. And in option D, it says when theta F is pi by 4, so when it's at an angle of pi by 4, the field is turned off. Right? If the field is turned off, the torque becomes 0 and the dipole will continue to rotate with a constant angular velocity. So option D is correct. So it's just B and D.
Okay. So look at the question number 5. The question number 3. The question says a beam of polychromatic light passes through a prism. Okay. Thin prism. So they gave a thin prism. So we know the formula for thin prism, right? So the minimum deviation for thin prism is given by mu minus 1 into A. Okay. And then they have also given you the condition for the refractive index, which is varying with the wavelength, which is like n of lambda is equal to alpha into lambda plus beta by lambda square. Okay, so we are supposed to find what is the D minimum for corresponding lambda minimum. Okay, so when do you get D minimum? So we are supposed to find lambda minimum. So how do you find lambda minimum? So they gave you refractive index is minimum, so you can find that. So D by D lambda of n of lambda will be equal to 0. Okay, so for the refractive index to be minimum, we know the condition for maxima and minima, right? So we just use that. Okay, so now you differentiate this, you will be getting alpha plus, this is like beta into minus 2 divided into lambda power minus 3, which is equal to 0. So this, if you solve, you can find you will get 2 beta divided by lambda cube equals alpha, right? So from this you solve for lambda. So I'll just write the answer. So this will be, upon substituting, you will be getting like 2b by alpha whole power 1 by 3. So put the values of beta. It's like 2 into 0.096 divided by 3 whole power 1 by 3. Okay, so this will be giving you a lambda minimum. Okay, so how much is a lambda minimum? So this turns out to be equal to 0.4. Okay, so now once you get lambda minimum, you can put that lambda minimum in this equation. Okay, so corresponding lambda minimum will be giving you the minimum refractive index, and then this relation now can be rewritten as, so d minimum is equal to, what is my mu minimum? So in the place of lambda, I can write lambda minimum. So what is my mu value? It will be alpha into lambda minimum plus beta by lambda minimum square, okay, minus 1 into angle of prism. Okay, now we have found how much is the lambda minimum for the corresponding minimum refractive index. So just put the numbers over here. So we know the values of alpha. So it is given to be 3 into 0.5. Alpha value is given to be 3. So this will be 3 into 0.4 plus beta value is given to be 0.096, right? So 0.096 divided by, and lambda minimum we have found 0.4, 0.4 square is 0.16 minus 1 into angle of prism is thin prism, right? So it is given to be 6 degrees. Okay, so now you can see, just put the, substitute it, and then you can solve for, so 3 into 0.4 is 1.2 plus this turns out to be 0.6 minus 1. Okay. Yes. So this is into 6 degrees. So 1.2 minus 1 is 0.2. 0.2 plus 0.6 is 0.8. 0.8 into 6 degrees, so which is equal to 4.8 degrees, which is our option B. Okay. So this is how you do the question number 3. Thank you.
Hello students, we discuss question number 5 of paper 2. Consider two isosceles prism 1 and 2 with prism angles A1 and A2 with respective indices N1 and N2 respectively as shown in figure. The faces A1, B1 and A2, B2 are parallel to each other and perpendicular to the mirror M. If a ray of light incident on the face A1, C1 and emerges from the face A2, C2, then the correct statements are. First we draw the diagram. This angle is theta, it is I1, it is E1 and it is I2 like this, it is A2, it is A1. Suppose it is R1 and it is R2. Now it is a mirror, just see here. If this angle is I2, it is 90 minus I2. If it is I1, it is horizontal line, it is 90 minus I1 parallel to mirror. That means these two angles are equal, therefore E1 is equal to I2 for all cases. In the first option, is given that if both prisms are in minimum deviation condition. In case of minimum deviation, this angle is A1 by 2. So N1 sine A1 by 2 is equal to sine E1. For second prism, N2 sine A2 by 2 is equal to sine I2. And E1 is equal to I2. So we write N2 sine A2 by 2 is equal to N1 sine A1 by 2. And in the first option, we find N2 by N1 is equal to sine A1 by 2 divided by sine A by 2. So it is correct. It is A option. In the B option, when prism 2 is at minimum deviation condition, only prism 2 is at minimum deviation condition, that means 1 into sine I2 is equal to N2 into sine A2 by 2. And I2 is always E1. So 1 into sine E1 is equal to N2 sine A2 by 2. And E1 not equal to I1 because it is not condition of minimum deviation. So sine I1 does not equal to N2 sine A2. So B is incorrect. In the C option, when angles are small, then delta M1 is equal to N1 minus 1 A1. Delta M2 is equal to N2 minus 1 A2. In this case, delta M1 upon 2 N1 minus 1 plus delta M2 upon 2 N2 minus 1 is equal to, from this equation, A1 by 2 plus A2 by 2. Now, see here. In this case, this angle, in this diagram, suppose this angle is theta 1, this angle is theta 2. So, this angle is equal to this angle and this angle is equal to this. So, it is A1 by 2, it is A2 by 2. Sum of these two angles means sum of these two angles. That means A1 by 2 plus A2 by 2 is equal to theta. It is equal to theta. So answer C is correct. In the D case, in the D part, sine I2. In the D option, prism 1 is minimum deviation. So in this case, if we write N1 into sine A1 by 2 for first prism is equal to 1 into sine E2 and sine E1, and sine E1 is sine I2. So it is correct. So D option is correct. So answer is A, C, D.
Hello. So here we are going to do question number 6, second paper advance. So what we have given here we have given charge 1 microcoulomb, and if we will change in the SI unit, so it will be 10 to the power minus 6 coulomb, and this charge is entering first in the electric field, and then after some time, after 0.2 second, the magnetic field will switch on and the electric field gets switched off after 0.2 second. So what we have to find here, let's say, so, and the mass of the particle is given 1 milligram. If I will change into the SI unit, so it will be 10 to the power minus 6 kg. Okay. So what we have given here, the particle is here, and let's say this is x-axis, this is y-axis, and this is z-axis, and the particle is entering perpendicular to the xy plane, xz plane. So here's the xz plane. So particle is entering here, and what is the initial speed of the particle? So velocity of the particle is I cap plus 2j cap. It is given in the question. Meter per second. So here I cap and 2j cap here. So let's say the particle is entering here with the initial speed u. Now what is going on here? Initially only electric field is acting here and the gravitational field is acting for the complete motion. So for 0 to 0.2 second, if I will analyze here, so what is the electric field is given? E equal to 1 I cap volt per meter, and gravitational field here we can take minus 10 j cap. So electric field is in the plus direction plus j, and gravitational field is acting downward minus 10 j cap. And first we will analyze from t equal to 0 to t equal to 0.2 second. So what is the force acting on the particle? Electric force acting equal to q times E vector. So now what is the charge of the particle? Charge of the particle is 10 to the power minus 6 coulomb. And what is the electric field here? Electric field is 1 I cap volt per meter. So if I will solve this one, I'll get 10 to the power minus 6 Newton force. That is the electric force acting on the particle. So what is the acceleration because of the electric field? So acceleration because of the electric field equal to mass times acceleration. And if I will write the mass of the particle is
10 to the power minus 6 kg. So what will be our acceleration here? So acceleration of the particle becomes, what is the direction of the force? Force direction is, electric force direction is plus j cap. So I can say acceleration becomes 1 meter per second square along, sorry, it is along the I cap. So electric field is acting here, electric field is acting along the x direction, gravitational field is acting along the negative y direction. So I can say the net acceleration on the particle because of the electric field and because of the gravitational field. So because of the electric field, what is the direction? Along the I cap. So 1 I cap means I cap. And what is the acceleration because of the gravitational? Minus 10 g cap. So here's the net acceleration acting on the particle for the time interval t equal to 0 to t equal to 0.2 second. So what we can find here, after 0.2 second, what will be the condition here? So let's say the final velocity after 0.2 second is v vector u plus a vector t. First equation. So now we will analyze for the x direction and y direction and z direction. So for the x direction, what is the vx here? Vx equal to, I can write ux plus ax t. Now what is the initial speed along the x direction? So initial speed is 1 meter per second. So 1. What is the acceleration along the x direction? So 1 into t. What is the time after 0.2 second we have to find? So it will be 1.2, and this is along the x direction, so vx. Now what about the vy? The speed in the vy direction after 0.2 seconds, so we can write uy plus a by t here. So what is the initial speed along the y direction? Initial speed along the y direction is 2. Now what is the acceleration along the y direction? Minus 10. So minus 10, and the time is after 0.2 second. We have to analyze this motion. So how much is this? It will be 2 minus, from here also again we will get a 2. So this is 0 meter per second. It means after 0.2 second we have the complete velocity along the x direction. It means the particle is moving something like this, and after 0.2 second the particle becomes exactly along the x direction. This is your v vector. So this is at t equal to 0.2 second. Okay, so now the particle has the velocity only along the x direction. Now we will analyze the particle after t equal to 0.2 to, I can say, whatever time is given. Let's say after 0.2 second. Here. Okay. Now magnetic field will turn on after 0.2 second. So electric field is off. So magnetic field on and electric field off. So now because the magnetic field is on and we have the velocity of the particle here, so we can say that here force will act F vector equal to Q V cross V. This is the magnetic force. So here we can write, what is the charge here? 10 to the power minus 6 coulomb. What is the velocity of the particle? 1.2 only along the x direction. So I can say 1.2 times I cap cross. What is the direction of the, what is the magnitude of the B? Magnetic field is given here 6 along the J cap. So from here we can get the force equal to, because of the magnetic field, 1.2 into 6, this is 7.2 into 10 to the power minus 6, so this is 7.2 into 10 to the power minus 6 Newton. Now from here you can say I cap cross J cap equal to K cap. So now the magnetic force is acting along the K cap. What is mean by this one? Now the magnetic force is acting here, gravitational force is acting downward. So I can say from the F equal to Q V cross V. What is the direction of the force? Along the K cap, and gravitational force is acting downward. So I can say here
Yes. Just erase.
it means only gravity will act along by direction, because what is the direction of the magnetic force? It is along the k cap, and we are analyzing along the by direction. So only gravity is acting here. And what is the magnitude of the gravitational force? You already know, it is 10 meter per second square downward. Now, so from here we know that the Vy equal to 0, so I can say the velocity along the y direction was 0. And we can find what is the position after 0.2 second of particle at 0.2 second. So along the y direction, what is the position of the particle? So I can use y equal to u by t plus half a by t square. So from here we can say, so what is the velocity? 0 minus half, what is the value of the gravitational acceleration? 10 t square. So if I will take here the velocity by equal to here, actually initial velocity was along the y direction 0.2. Initial velocity was 2 j cap, so 2 into 0.2 minus 10 gravitational acceleration into 0.2 chi square time chi square. So from here we will get 0.2 meter, and that is equal to 20 meter. So the particle will reach here along the y direction 20 centimeter. This is in centimeter. Okay, now magnetic force is acting along the k cap, gravitational field is acting downward. So we can say in the options what we have to find here, we have to find where is the particle at 0.3 second. It means from 0.2 to 0.3, what is the displacement of the particle along the y direction? Or what is the displacement of the particle from the xz plane? So I can write here, so along the y direction, what is the displacement? Y equal to u by, what is the u by finally? At the 0.2 second we know that it is 0. So there is no velocity, you can say the complete velocity along the x direction. So there is no velocity along the y direction, so I can say at 0.2 second the velocity is 0, initial velocity 0 minus only gravitational force is acting downward because the magnetic force is acting perpendicular to the y direction. So only gravitational force is acting, so half into what is the acceleration because of the gravity? Minus 10 into t, 0.2 0.3 for this time interval, the time is 0.1 square. So now what is the displacement of the particle in this 0.1 second? So from here you can see 0.01 into 10, so 0.1 upon 2, so I will get here in this second it will be 0.05 meter. It means this is 5 centimeter displacement will be there. So if I will count, this will come 5 centimeter, because the minus sign is here means the displacement is negative. So from the ground, from the xz plane, what is the displacement if the particle is coming here 5 centimeter down? So I can say from here the height of the particle is 15 centimeter. So if you will see the option A, the vertical distance of the particle from the xz plane at t equal to 0.3 second is 15 centimeter. So here we can clearly see from the xz plane the particle displacement is 15 centimeter after 0.3 second from t equal to 0 second. Now next option is the vertical distance of the particle from the xz plane at 0.4 second. So now after 0.4 second, where is the particle? So after 0.2 second, the particle is here at 20 centimeter height. So we have to find 0.2 to 0.4. So what is the time from here to here? 0.2 second to 0.4 second means in 2 seconds, what is the displacement of the particle from here? Because now the particle is here at 0.2 second. So we can say y equal to again u by t plus half a by t square. So what is the uy? Initially the particle speed is 0 at 0.2 second. You can see here it is along the x direction. So minus half, gravitational acceleration is minus 10 into t. So from 0.2 second to 0.4 second means 0.2 second square. So in this 0.2 second, after this movement, what is the displacement of the particle? So minus 2 5s are here, 0.04 into 5. So here we will get directly 0.02 meter. It means 20 centimeter. It means now the particle is here. If the displacement is negative 20 centimeter, means the particle comes to the xz plane. So what is in the option? In the option we have given the vertical distance of the particle from the xz plane at t equal to 0.4 is 10 centimeter. So we can see clearly the particle displacement becomes 0. Okay, so option B is incorrect. Now come to the option C. In the option C, what we have to find? The radius of the trajectory of the particle for t greater than 0.2 second is 20 centimeter. So now what is going on here? Look at here. The magnetic force is here, the gravity is acting downward. So because of that, the particle is experiencing the force this side, and because of the gravity, it is moving downward. So because of the magnetic field, the particle will move in a circular path, and because of the gravity, the particle is moving downward. So what is going on here? The particle is moving in the circle also, and it is moving the downward. So it will make the helical path. So now, and we know that the radius of curvature for the circle it is equal to r equal to m v by q b. What is the mass of the particle? The mass of the particle is 10 to the power minus 6 kg. What is the velocity of the particle? It is 1.2 meter per second. You can see the velocity is here 1.2 meter per second. This is kg here upon. What is the charge on the particle? 10 to the power minus 6 coulomb into what is the magnetic field here? It is given here 6 Tesla. So from here we'll get, this will get cancelled. So this is here 0.2 meter. It means 20 centimeter. So in the option, the radius of trajectory of the particle for t greater than 0.2 is 20 centimeter. So option C is also correct. Now come to the option D. So in the option D, the particle will be at in the xz plane at t equal to 0.35 second. So from the this calculation we already got after 0.4 second the particle comes to the xz plane. Okay, in the 0.4 second complete time, 0.4 second it comes to the ground. In this option we have given the particle will be in the xz plane at t equal to 0.35 second, but the particle is coming to the xz plane after 0.4 second. So particle will not be at the ground, it will be somewhere here, not on the ground, because after 0.4 second it is coming here, means in the 0.35 second the particle will be somewhere here. So that's why the option D is also incorrect. So what is the correct option? The correct option is A and C. These two are the correct answers. Thank you.
Hello. So today we will solve that JEE Advanced paper 2, question number 17 and question number 18. Basically, this is a paragraph type questions, and we will first go through that questions. That it is given that question number 17. It is a uniform circular disc is there, and the radius is given, that is 0.2 meter, and the mass of this disc is given, mass is given 1 kg. Another data is given somewhere at point P. One small particle having mass m equal to, it is given 20 gram, strikes at this point P, and after striking it is going at an angle 90 degree along the y-axis down the plane. Okay, so basically whenever these things happen, question is that after collision the particle moves along the negative y direction at a speed of 90 meter per second. Initially it is moving with 100 meter per second given, and now it is moving with a speed of 90 meter per second. Now question is, find the after the collision the disc starts to rotate around the point C. So first thing we will see here, torque about the point C will be equal to 0. If torque is 0, then I can say initial angular momentum is equal to final angular momentum. That because when the torque is 0, then angular momentum is getting conserved. Now initial angular momentum of this particle will be, I will write like this thing. See here. So first one is m, that's for particle, mu into, when it is going to hit at this point, I need to calculate this distance, perpendicular distance. Till this much is r, this much. If it is striking, and the question it is given, it is striking, or this one angle is given 45 degree, this angle. So obviously this distance will be, I can write r cos 45, this distance will be r sin 45. Now, so I can write for the first one mu r plus r cos 45, done, because this much angle is r and this much will be r cos 45, so total one will be mu r plus r cos 45, and the final one will be that mv only for this particle is going, so this is supposed to be the perpendicular distance, this one will be r sin 45 plus with, why plus? Because after striking this disc will also rotate, so it is rotating with an angular momentum of I into omega, this is id. Now this is point C, it has to rotate about this point C about this axis. So how to calculate the moment of inertia of this one? Now we will consider another axis here which is passing through the center O. So I will write this one, this id omega I will write like this, half mr square, that is the moment of inertia about an axis passing through the center, plus mass into this distance square. I am using the parallel axis theorem. Okay. Now if I will write these values, that m will be 20 by 1000, this is velocity is 100 initial one, this one is 0.2 plus 0.2 by root 2 equal to, then this one will be again 20 by 1000, okay, multiplied with v will be 90, again 0.2 by root 2. If I will solve this part, here capital M you can put that 1 kg and r equal to 0.2. This part becomes how much? 3 by 2 mr square. If I will put that one and I will solve this one, you are supposed to get omega as 7.138 radian per second. Okay, omega is equal to 7.138 radian per second. Now question is what? Now question is, after the collisions, how much the maximum height will change? Now I will apply conservation of mechanical energy. Conservation of mechanical energy. Now see here, what I am doing? Now half I omega square equal to mg into delta h. Done. That is the delta h is the change in the height of the position of the center of mass. Okay, so I am getting half it is not exactly the center of mass, it is the center, how much the center will get shifted. So half I will be 3 by 2 mr square, whatever the things we have got from here. Omega is 7.138 whole square. Small m is that mass is given. Okay, that is the capital M, that is 1 mass of the disc. Z is given 10. I need to calculate this delta H. So this one I am getting 3 by 4. Capital M is 1 kg. Capital M is 1 kg and R will be 0.2 square, 7.138 square. This one will be 10 delta H. So if I will solve this one, I am getting delta H on 0.15 meter. Done. This is the question number 17. Now I will go to the question number 18. Question number 18 is what? Find the amount of energy loss in the collisions. Find the amount of energy loss in the collisions. Now for question number 18, first we will calculate the initial energy. For the particle, initial energy is simply half mu square. So that will be half m will be 20 gram is given. So 20 by 1000. U is given 100 square. If I will solve, I am getting initial kinetic energy as 100 J. I am getting 100 J. Now the final one. After when it will strike this particle will strike, then there will be one energy along the y direction. Okay, as it is moving along the y direction, so it has the certain kinetic energy, as well as another thing is that the disk will start to rotate, which is initially at rest. If it is initially at rest, so that's the kinetic energy of the disk is 0. So I am getting here half mv square plus that energy will be half I omega square. So now half this m will be 20 by 1000 v square, that is 90 square, plus half I will be 3 by 2, capital M is 1, R is 0.2 square, 3 by 2 mr square, omega is 7.138 square. Okay, then if I will solve this one, I am getting this part as that we are getting this part as 82.53. We are getting 82.53. Now change in energy delta E will be energy initial minus energy final. This one will be 100 J minus 82.53 J, which will give you 17.47 J. 17.47 J. Okay. So as we are doing the initial minus final and we are getting the positive energy, so that means energy is lost. This much is done. Thank you.
Good evening again, students. So we are dealing with the question number 9. As you can see, question number 9 is presented on the screen. 10 moles of an ideal monatomic gas initially is at a state A at atmospheric pressure and temperature of 27 degrees Celsius. It is enclosed in a metal cylinder of volume V0 fitted with a frictionless piston. The gas is suddenly compressed to a state B. So sudden compression means adiabatic process, definitely. So process A to B must be a adiabatic process, and it's the volume V0 by 3. Now keeping the piston stationary, the cylinder is submerged in a water bath of temperature 11 degrees Celsius until the gas reaches the temperature of water bath, which is denoted as at state C. Okay, then it is like a with this constant volume, that must be isobaric process, isochoric process. Finally, while still in a water bath, the piston is brought slowly to its initial position. From that statement we can understand, as it is bringing slowly, it is a isothermal process, and yeah, it brought to final temperature must be temperature of the water bath, that is 11 degrees Celsius. If R is a universal gas constant, then correct options are. So let us verify. First question, they were asking schematic diagram. Let us see if this schematic diagram follows or not. As I was saying, process A to B is adiabatic process, quick process. Then process B to C must be isochoric process, constant volume. Then again from process C to F, it is definitely isothermal process. Now with these things I can say that, let me first derive the things. Process A to B process, adiabatic. What are we going to deal with over here? Let me take the given values. Number of moles is given as a 10, and what else we can say? Adiabatic ratio can be 5/3 for ideal monatomic gas. Now, as temperature at A is given, temperature at A is 27 degrees Celsius. That can be written in a form of Kelvin, 300 Kelvin, and temperature at B point I want to find. So how can we take a temperature at point B with the relation of what was that relation? T V to the power gamma minus 1 is a constant relation. From this I can write final temperature. Temperature at B can be written as temperature at A times of VA upon VB whole to the power gamma minus 1. If I substitute the values of 300 times, and VA is V0, let me say, VB is V0 by 3 as given in the question, and 5/3 minus 1 would leads to 2/3 times. And yeah, and that would give you answer of 624 Kelvin. So the temperature at point B when adiabatically brought back from A to B is 624 Kelvin. Now pressure also let us see. We know that P V power gamma is constant. With this relation I can say that pressure at point B is equals to pressure at point A times of VA VB whole to the power gamma. Pressure at A is nothing but atmospheric pressure as given in the question, and volumes also we know that V0 upon V0 by 3 whole to the power gamma. And pressure at B, if I can substitute the values, gamma value is 5/3 times. Yeah, if I can consider like that, this would lead to 6.24 times of P atmospheric pressure. This is what I got. And one of the options they were mentioning, the pressure and temperature at state B are 2.08 times the atmospheric pressure and 624 Kelvin. Yeah, obviously the temperature is 624 Kelvin as we got from here, but as you can see the pressure is, it's not a 2.08 times, but it is 6.24 times. So obviously I can say from that option D is wrong. D option, one second. Yeah, option D wrong. I'm not going in an order because as I am deriving, I'm checking for the options, whichever is matching. So option D has come to a wrong one. Now let us see. Option B was asking the change in internal energy is going from state A to B is. Now I need to keep these things as it is. Now let me erase the portion before that we discussed from here. Yeah, the change in internal energy can be written as from A to B. Change in internal energy from A to B. Delta U A to B can be written as NCV delta T, specific heat of a gas at a constant volume. There we can say 10 times of 3 by 2 R times of change in temperature is like a TB minus TA 624 minus 300, and that would give me change in AB is 4860 times of R. Yes. So from this we can say option B is correct. Option B is correct. Now let us see for option C, the net change in the internal energy. So that is a total change. The total change in internal energy can be written as again NCV times of temperature at F minus temperature at A. So internal energy is independent of the path forward. We better check from the initial to final. Initial is A and final is a F point. And if I substitute the same manner, so what do I get here again? 10 times of 3 by 2 R. So temperature at F point is, it is a water bath temperature, and how much is that? Let me write here. Temperature at F will be equal to 11 degrees Celsius, that is equals to 284, right? 284 Kelvin. Yeah. So if I can do that, 284 minus 300, that would give me a negative value. So it is a minus, I am getting it as like a overall 240 times of R. Yeah, this concludes that option C is also correct. Option C is also correct answer. Now we need to verify the option A over here, graph, and let me, I can take that. Look at here, if I can draw a graph between pressure versus volume. Yeah, pressure versus volume. Let me say that it is starting from point A. It's the graphs are given like this. Let me say, yeah, starting from point A, adiabatic process, so it's going to rise up to B point, and isochoric process till C, and it is also going to finally to C, and it is following the graph looks similar. Let me say question says like finally it is reached to the initial position. Initial position in the sense maybe a same volume but not the same temperature. So these point A and F no need to be touching each other because here it is a 27 degrees Celsius, temperature at A is like a 300 Kelvin, and temperature at F will be like a 284 Kelvin. That is the reason. And yeah, option A is also correct. That's it. Thank you.
Can I? Hi everyone. So here we are going to discuss question number 13. In this question, so what we have to find out, we have to find out the current through this resistor R1. So first in the question they are given, when it is open, when the key is open, the current through this is Ig, which means this is the key. Now this, when the key is closed, we can call it as Ig1, current through the galvanometer. So this is the situation. So we need to find out the current through the R1. So for that, first one we can understand the question they have given this Ig1 is nothing but what it was. Ig1 is nothing but half of the initial current, that is nothing but Ig. Okay, this is the thing. So when it is open, the current will be what? The current will be flowing through here only, right? When the key is open. So you can find out what the resistance. The resistance will be what? The resistance will be nothing but Ig. This is the current going through this. So whatever the EMF of the battery, EMF is 10 volt. So 10 divided by what we have to do, we have to calculate the total resistance. What about the resistance? Resistance of the galvanometer and this R1. So it will be R1 plus resistance of the galvanometer. This will be 10 by R1, we don't know, but we know the resistance of the galvanometer. It is given in the question, that is nothing but 6 ohm. So we got Ig. Now when it is connecting, here there will be the resistance of the galvanometer, or there will be R2, then that will be in parallel. For that parallel combination, what will be the resistance? Resistance will be R2 into Rg divided by R2 plus Rg. So that will be Rp. Rp will be equals. So R2 is given, that is 4 ohm in the question. And what about the Rg is 6. So we will be getting 6 into 4 divided by 6 plus 4, that will be equal to 2.4. We got the Rp. And what about the total resistance? Total resistance means this parallel combination as well as this one, right? So the total resistance R will be equals R1, but we don't know, that is 2.4 ohm. This will be the total resistance. Now what we have to do? We have to find out the current through this R1. Let's say R1 is the current through the R1, resistance R1. So what we can do? That will be equals the potential difference or the EMF of the battery divided by what? Total resistance. That will be R1 plus 2.4 ohm. So if we are able to find out this R1, then we can get what? We can get the value of IR1. So now here we can say the current is coming and going like this. So current through R2 plus current through this galvanometer in what condition? In the closed condition will be equal to what? IR1. From here we can find out Ig1, that will be equals IR1 into R2 divided by Rg plus R2. So how we can do this? This IR2 you can convert in terms of what? Ig1, then you can get this relation. So you got Ig1 here. Ig1 is nothing but Ig by 2, that equal to IR1 into R2 is nothing but R2 we got. R2 is nothing but what it was? R2 is 4 ohm. Then divided by 6 plus 4, we got it here. IR1 we already have here, that will be equals 10 divided by R1 plus 2.4 into 0.4, that is nothing but Ig by 2. Ig already we have. What is Ig? Ig is 10 by R1 plus 2. If I am dividing it with the 2, what I will get? This become 5, right? So 5 divided by R1 plus 6. This will be the, if I am solving, I will get R1. If I am getting R1, I can find out the current through the R1 resistance R1. So here it will be So if I am multiplying this, I will get 5 times R1 plus 12 equals, this become 10 into 0.4, 4 it will come, 4 times R1 plus 24. So R1 will be equals 12 ohm. So I got R1. Now you can substitute in that equation. So here we can erase this and we can substitute for that. So R1 will be equals 10 divided by R1 is nothing but 12 plus 2.4. You will get 10 by 14.4. This will be equal to 0.69, for it will go like this. So in milliampere, R1 will be equal 694 milliampere. So this will be the answer. So thank you everyone.
Hello everyone. So with all these answers, probably you would have got the basic idea of like how things are. But let's have a overview of what and all happened and what kind of questions are posed in our paper 2. So let us go through each question with a case. Sir, usually this second paper, right, they will take it after their first paper, right? Like after that mindset of going through all these tougher questions. How one student will feel after this?
In the first paper, students being fresh mood. In the second paper, they tired. So same level of paper, they feel more difficult.
Okay. So meaning even though like some questions are easy, they might feel little difficult because
because they are tired.
Yes. Okay. So sir, let's go question by question. So what is the logic of first question, sir?
First question is concept based question, and similar question we have discussed in the class, and it is only formula based question, that is due to velocity and current and
so direct formula based
questions, and many students attempted correctly.
So we can say that it is the easier side question.
Easier side.
Right. Okay. Second question, sir.
Second question, it is on radioactivity modern physics question, and similar question was asked many years before, in which number of nuclei are producing at constant rate, and similar question we have also practiced in the class to students. So I think many students have attempted correctly.
So only they should know how to connect the thermal physics a bit with nuclear, right? Okay. So next one, sir. So next one.
Third one is geometrical optics question, and it is also easy question. Just differentiate dn by d lambda becomes 0 and find lambda.
Okay.
And after that n and b find u and deviation. It is also easy side question.
Yes.
And mostly attempted correctly.
Yes. And question number 4, I myself discussed this one. So this has more of NLM and SHM, little bit of angular momentum. So all the
it is a
mechanics,
standard to
standard question, right?
There are many concepts involved in this question.
Yes. So fifth question.
Fifth question, geometrical office question. It is also a standard question
Okay.
because it involves 2 prism and 1 mirror.
Yes.
Generally we practice question 1 prism 1 mirror, but it is asking the 2 prism and 1 mirror.
Yes.
So and based on minimum deviation concept and the reflection, refraction, etc. So mostly students attempt correctly.
Yeah. So how can we classify this one, sir? Like
Standard
right?
question.
Okay. Sixth one, sir. It has, I think.
It has electric field and magnetic field and velocity. All.
Gravity
So it
was also there.
Gravity also there. So it is standard type question.
Okay. So we can say that it will not challenge that much, but doable, right? So seventh question, sir.
Seventh question, similar question asked in many years before in JEE, but in that case only 2 point charges plus 2 and minus 2 are there, and we find locus of the equipotential points in xy plane. Here it is tougher side because here m term used, m is minus 2, plus 2 and minus 3. So it is more calculation and extended to tougher side.
Okay. Sir, what about eighth question?
It is electrostatic question and based on energy conservation and dipole moment question, and it is also easy to standard.
Sir, even like few years back, we have similar kind of questions
similar kind
on
of question,
dipole moment and energy related.
Right.
So ninth question. Ninth question,
thermodynamics question, and many questions we have done practice in the class is adiabatic process, isochoric and isothermal process, and I think mostly students attempt correctly this question.
Yes, sir. Because we in our revision program, right, we had all these kind of questions, right?
Right.
So, sir, what about this 10th question, sir?
It is measurement and error based question, and it is also easy question, and mostly students attempt correctly.
Yes. So I think first year students can try this problem, right? Yes. So then, sir, 11th question.
It is wave office question including error concept. So it is also easy side question, mostly students attempt correctly.
Meaning if they would have taken this paper, meaning without having the tire effect, right? Like tiring effect. So
Mostly
they can
attempt
do
correctly,
really well, right? So what about 12th question?
12 wave office question just based on Brewster's law. It is also easy question and mostly attempted correctly.
Okay. So what about 13th?
Question number 13.
So we have
electricity question. It is
Yes.
standard question.
Okay.
And we have also practiced this type of questions many times in test and class also.
Yes.
And I think also most students attempt correctly it.
Yes. Okay. So 14th question, I think it's the easiest.
It is easiest because it is only dimension form concept.
Yes.
And mostly attempt correctly it also.
And after the easiest problem like this, they'll have this 15 and 16. Sir.
15 and 16. It is toughest problem.
Tough. So I think they will be like completely, getting that feel of advance with all these calculations.
This type of question asked in first time.
First time. Yeah. So, but they would have, they need a lot of time for this. Yeah.
Lot of time.
Then 17, 18, sir.
17, 18 there is a standard question and based on angular momentum conservation, energy conservation. And I think many students attempt correctly because we have practiced too much questions on this.
Okay. So, sir, overall, like, suppose if we have to give them summary, like, which chapters carried whole lot of weightage in.
If we conclude paper 1, paper 2 both, then we can say that RBD have too much questions,
Yes.
too many weightage.
Yes.
RBD, EMI have more weightage, and thermodynamics, SHM also
Yes.
have more.
So
weightage.
I think like when compared to previous years, this year it is like made to be like little bit on tougher side because of involvement of too much of RBD and SHM.
Right. RBD questions are more, and generally students avoid to
practice on RBD and attempted question on RBD, but according to these two papers,
Yes.
You can't leave this chapter.
Yes.
You must prepare this chapter and attempt questions on
Yes.
this.
So those first year students who would have neglected, you know that RBD will be asked like this in different varieties. So make sure you become stronger in all those areas. Okay, sir, you want to conclude both paper 1 and paper 2 put together, like what can we say, like 2026 JEE Advanced, like first paper, second paper put together, RBD, thermodynamics, SHM, EMI. This ruled entire thing. Yeah.
Right.
And as fillers, we have all other chapters, right?
Right.
Okay. So thank you, everyone. So I hope you would have enjoyed this. So you can share to your friends as well, and they will get benefited out of this. Thank you. Thank you so much.
Thank you.